here we go. All right, so the first question is an inequality question. Now, again, I'm assuming all of you are J1s. Oops, sorry. I'm assuming all of you are J1s. So therefore, this kind of question bound to come out for your test, okay? Because in J1, you don't really have a lot of tests, a lot of things to test you at the moment. All right, so of course, now the one thing that I do want to note when talk about inequalities with students whom I didn't teach them inequalities is that there are different style of doing it. Okay, even within my own students, when they go to school and they learn, they may learn the style from the teacher. Okay, now it's not wrong, it's just different style. All right, so what I'm doing may not be entirely what you are too used to or what you are too familiar with. Okay, but generally the idea is there. Okay, just that maybe I did it a little bit differently. Some of you may heard of sign test. Some of you may be doing like what I'll be doing, something like draw a curve. Okay, that sort of thing. All right, so let's run through quickly. But again, any doubt you have, just ask. Okay, I'll be happy to guide you along. Okay, it's not my teacher never teach me this way. Just ask. Okay. Anyways, our job is to solve this. Now the question says use algebraic method. You know what that means? Do not use a GC. Pretty obvious, right? Okay. Then there's a hands and then and so on and so forth. So we have to use this answer. Of course, we have to get this answer correct first. All right, because we get this answer wrong, then everything else will be affected, and I would say very badly affected. Okay, so how I like to do for inequalities is this. I like to move everything over to one side, which is the left side. Hold on, okay. Okay, now the reason being that when I switch everything over to the left side, on the right side it becomes 0. And when it's 0, I don't have to handle it too much. In fact, I don't have to handle it at all, because no matter what I do, multiply throughout by anything else, it will always be 0 there. So that sounds like a good idea. The next thing is, of course, make it into a single fraction, and that's called the LCM, or called common denominator in secondary school. All right, now, of course, in this case, you do want to watch it that you already have the denominator to be quite similar. I mean, there's x there, there's x there. So the LCM is actually just this. Okay, so in some sense you already know that well, the common denominator is not that bad, to be really honest. It's just this. Okay, so what you have is going to be x plus 4 minus with x plus x. Okay, just remember change the sign, it should be quite fine. All right, so you're going to get 2x minus 3 plus 3 over x of this. Okay, now generally whether I mean, most of the time, I do think that this is not difficult to understand. Okay, this is probably like, okay, no, I will do it myself kind of feel, right? Now, here comes the part that can be a little bit different, okay, going forward. All right, now what I like to do, okay, or what I taught my students is that they multiply throughout by the square of the denominator. Okay, the whole idea of this being A level, right, is the fact that in A level we have to learn this trick called multiplying throughout by the square. The reason is if you multiply by a negative number, then you may have to change the sign. I mean, you have to change the sign, correct? So when you multiply by x throughout, then you don't know whether this x is positive or negative. Then you have a problem because you're not too sure whether you need to change the sign or not, right? So to make it really sure, we multiply by the square. Therefore, it's always positive. And again, you probably sense that, hey, that's a good idea to keep the right-hand side 0, because you get kind of free there right now. In fact, the green color part, you don't even need to write. Okay, you don't even need to show the green color part that I just showed you. The reason I'm showing it is because, again, maybe you don't learn it this way in school, so you'll be quite puzzled if I just tell you, oh, guys, this is what I'm going to get the next step. Okay, but of course, if you see the green color part, you probably can understand how I get the next step, correct? Hold on, this not very balanced. Okay, here we go. Agree? Okay, now then what we have here is a simple quadratic inequality. All right, now this cubic. Okay, but the whole idea is, well, after all, there are just 3 roots. Okay, so the 3 roots are like at -4, -3, and 0. Okay, and of course, you do know that the curve look a bit like this. All right, now, okay, again, I'm not too sure. I'm assuming not every one of you are familiar with sketching this curve. Okay, so you say, Mr. Ang, why like that and why not like this? How do you know which is true? I mean, the whole idea is you must pass through the 3 roots. You must pass through because these are the roots, right? So if you must pass through the 3 roots, there are 2 ways to draw this dragon, right? You either draw it this way or you draw it that way. Okay, so how I taught my students is this. Okay, so you pay attention to the highest power. If the highest power, which is cube, is positive, the curve ends up. So that means to say the curve will be ended up there. All right. Now another way you can try to do this is to put in a value for x, like maybe anything more than 1, right? Anything more than 0, like 1 or something. So you end up positive. So you end up knowing that the curve has to look like this. Okay. Hold on. We have another guess. That's what I meant by a bit of disruption. Okay. Anyways, so we got this, and of course, what we want to be from all the parts that are positive, which is above the x-axis. So we're going to get the answer -4 to -3, and then x is greater than 0. Okay, this is 3/2. Sorry, my bad. Okay, so I forgot that 3/2 over there. All right, so this is -3/2, and x is more than 0. Okay, so there you go, but hold it, you are not going to get full marks yet. Okay, so what is up is this one, right? So it comes with an equal sign. Now, one thing that you should be nag on, okay, I like to call myself nagging, right? Okay, because I nag a lot to my students, and that's like you today. Okay, so the idea is important. You have to inherit this equal sign as your answer, but you don't blindly inherit everywhere. Okay, so better be careful, because you must understand that your original question is this one, which is okay, the same as this. Maybe I don't have to scroll up and down. Okay, so it is this. And whenever you have a fraction, right, at your level, you better be crystal clear that you cannot have a denominator that is 0. So if you look at the denominator, all right, and you realize that, oh, x cannot be equal to 0, then you jolly well don't put equal here. Okay, x cannot be equal to, which number again? 4, -4 as well. So this is fine. Okay, so this equal sign is fine, the rest are not fine. Okay, now there you go, 3 marks for you. Now, it's a 3 marks question, so how do you get your 3 marks? Well, first of all, of course, 1 mark goes to the answer, the final answer, you deserve 1 mark. Now, and of course, how you get the answer, okay, over here. Now, again, most of you may be familiar with what the school taught you called sign test, okay, which is roughly the same as this, except you all don't draw the graph, right? Sign test would be something like this. I don't like sign test myself, because I think it's a waste of time. Okay, imagine you put in a number, check plus or minus, put another number here, check plus or minus, put another number here, check plus or minus, where if you can draw the graph fast, you do it in 1 second. Okay, so of course, if you get the sign test, it's fine. All right, you get 1 mark too. All right, and of course, the other 1 mark is of course going into the simplifying. Okay, so if you happen to be able to simplify nicely, correctly, you get a 1 mark. So 3 marks is rather generous if you ask me. Okay, but well, J1 is being J1. They don't want to be too demoralized, actually. Okay, so there you go. All right, I don't think you have any questions. Come, let's move on to part 1. Okay, now part 1, as you can probably see, all right, now if you look at this and you look at this, just side by side. Okay, they're not really side by side, but my point is just look at them together. Know how to tell, right? Yeah, it's seriously know how to tell. Okay, so it's obvious, really. Okay, if you missed it, I don't know what's going on. Okay, how can you miss this, right? You're just going to say, oh, you know what? I'm going to let x be mod x. That's it. Okay, so your question, all right? Your question, hold on, I got another one. Okay, now your question, which is this nonsense, the original question was this. Hi, welcome, join us, please. But we already started. Okay, here we go. Okay, so your original question, all right, with the answer that we found, and now we're gonna let x be mod x. Everything is just gonna be substituted. Okay, and there you go. You get the question. All right, now some of you may be a little bit puzzled. I hope not, but in case you are, you better know that the x squared is the same as mod x squared. Okay, the mod is redundant. All right, because after all, whether you square or you don't square, you mod or you don't mod, it's going to be positive anyway. All right, so this mod is actually pretty redundant. So, all right, so we understand that we actually have the answer for this in the previous part, and therefore you actually just write down your answer like this. Okay, it's only 2 marks. 1 mark goes to the substitution. 1 mark goes to the final answer. It's pretty easy 2 marks to get, if you ask me. All right, so you just write this arrow. I don't know whether you know this or not. This symbol is a mathematical symbol, by the way. Okay, it literally means implies that. Okay, implies that. All right, so implies this. Now, of course, you better know that that's not the end of the day, okay? So this is not applicable, because how can a mod number be between some negative number? That's ridiculous. Okay, cool. All right, and therefore, that itself is not applicable. Now, some of you may be too comfortable with this, and you say, oh, Mr. Ang, that's my answer. Now, I don't think you're going to get 1 mark, okay? Because this is being too lazy, all right? Now, and then what's this answer, right? So x is more than 0, x is less than 0. Okay, and actually that's it. That's the answer. Actually, or simply put, like I think the answer key at the back suggests that x are all real numbers except 0. Okay, so you can do either of this. They're fine. All right, just be aware that any number you put inside will be positive, correct? So any number you put inside confirm will be more than 0, correct? Yeah, but except one number. If you put 0 inside, it will not be more than 0. Okay, and that's why you must exclude that 0. That's all. Okay, it's a simple 2 marks. All right, and like I say, it's obvious. The substitution is obvious. So, okay, I don't think I have much to nag anymore on this one. Okay, let's move along to part 2. Okay. Now, part 2 will be, I would say, well, probably slightly more challenging. Okay, why did I say that? Well, because if you look at this question that you have solved, and you look at this question that you're trying to solve using the answer, you probably have a sense that I don't know what to substitute. Okay, and it's true, because it's not so obvious or not so easy to tell, to see that, hey, you know, just now that one was so easy, right? Like this, come on, this is like mod x, and you can see where the mod x all happening, right? There you go, right? It's everywhere. So it's obvious when it's obvious. Okay, when it's not obvious, you go like, oh, I'm a bit stuck. Now, of course, then you look out for hints. Okay, you don't just give up and say, oh, you know what, I'm dead. All right, so take a look at this. This is by far probably the most unique or the easiest to spot kind of fraction inside the question, and you probably can see that there's a 1 over something as well. Okay, so your biggest bet right now, and your biggest guess, okay, will be, you know what, maybe I'm going to let x be x minus 2. Okay, and of course, like I said, in the exam, there's no 100% guess correct all the time, but of course the idea is this is probably the best guess already. What else are you guessing? I mean, the rest are not so obvious, but this is obvious. Okay, so if this is obvious, then why don't you just try? So what you ought to do is this. Okay, remember that we already solved the part 1's answer, right? Let me just copy down the part 1's question one more time. Okay, so which is this one. Okay, all right, so this is the original question. So if it works out, okay, if it works out, then I should be able to use this answer that I found to solve this. Okay, now I'm not a big fan of this scrolling up and down thing, okay? It makes me giddy. So I'm going to just, yeah, put this here, all right, side by side, so we can see the progress, okay? Now, so let's try, okay? So if I were to change all my x to x minus 2, what will happen, right? So it becomes, well, x minus 2. Okay, so let me write neatly, x minus 2. 1 minus away x minus 2, and this becomes x minus 2 squared plus x 4 times x minus 2. Well, I say, Mr. Ang, it doesn't quite look like anything like this. Well, maybe because I haven't simplified, but you see this? Yeah, that will be helpful. Okay, but the rest doesn't look so friendly yet. Okay, maybe we shall try. Continue on, right? Press on. So, hey, we do see a 3 minus x. Okay, how about the bottom? Let's hope and pray that the bottom actually looks like this, correct? We shall try. So we're going to have x squared minus 4x plus 4, okay? Minus 4x plus 4, and then plus 4x minus 8. So you do have a sense that things are falling into place, which is awesome, right? Because this and this cancel, and then get x squared minus 4. So indeed, it works. Okay, so you got 1 mark already. All right, so the 1 mark is for you to identify the correct substitute. Okay, all right, so that's important, guys. How come I can change color? Okay, never mind. All right, now next, of course, you say, okay, I know the substitute. I can use this answer. All right, I can use this answer. Okay, so but hold it. Cannot be too hasty as well, because you realize one more thing that you should realize. Okay, is this: the sign is opposite. Okay, now this is going to be something that I would say careless people or people who are in a rush, trying to rush things very fast, quickly and all. It's going to have a problem because usually what I saw before for students, okay, what happened is this, all right? They saw that this is now the same as the question, right? And they get excited and they say that, oh, you know what? This is the answer, or rather this was the answer. So now my answer will be simply this. Okay, just changing all the x to x minus 2. Correct? And they're going on and do, sorry, this will be all wrong. Okay? All right, and you better know why. And the simple reason is because you got the sign wrong. All right, so that's it. So how do we resolve this? Well, turns out it's not as bad as you think. There are two ways you want to do this, really. One way is to just go and change all the sign, but it looks weird, to be really honest. Another way, which I more prefer, is to look at this answer that you found earlier and ask yourself this: how do you get this answer just now? You were looking at this part, right? Correct or not? And now what you want is the negative part. So pretty obvious will be your x minus 2, okay? It's going to be less than minus 4. Your x minus 2, right, is going to be between minus 3 over 2 to 0. Sorry, not x, but x minus 2. Are you following? All right, now this is important, okay? Getting this is important because you don't just copy and paste the answer here, all right? So this deserves 1 mark, okay? This deserves 1 mark because of the fact that you are alert enough that you can tell that the sign is being opposite there. And of course, the last 1 mark goes to getting the correct answer by yourself, right? So you're going to get this, and add 2 throughout, you're going to get half, and you're going to get 2, all right? And we are done, okay? All right, any questions, anyone? Quickly. All right, so the substitute itself is 1 mark. Being able to get to here is 1 mark, and then final answer 1 mark. Okay, so there you go. Okay, no further questions. Like I said, you all can just ask. I won't stop you. But of course, if no question, then we better move on, right? We have like total quite a lot of questions to do. Okay. All right, come, let's move on to the next one. Question 2. Okay, this is interesting question. Okay, you give me a while. Suddenly it gets too noisy outside. Okay, so I better go and close up the window. Okay, here we go. All right, now this next question, some people has got a different feel to it altogether because they didn't realize that this was even a simultaneous equation question. Okay, so in any case, it does sound a bit weird, to be really honest, right? It read like, there's a ball rolling on surface, distance and so on, and time and all. But actually, you just have to read very carefully. Okay, it's just trying to tell you that this y is the total distance traveled. All right, it's like a formula, right? And t is the time taken in seconds. Okay, so it's at the starting point means you haven't traveled anything. So the first thing that they're trying to tell you is that t equals 0, y is equal to 0. Put the information in, that's all. So you probably can guess that, oh, I'm going to get y equals to 0 plus b plus c. The moment you write this down, all right, you probably have the sense that, wait a minute, I'm supposed to find a, b, c. So if I form an equation with b and c so easily, it must be a simultaneous equation kind of question. Okay, all right, so that's the kind of feel that you must have. Then you read more, read on for more information, right? That's the first 8 seconds. All right, you're going to travel 10. Okay, so there you go. Pretty easy, right? So I have 10a, and then I'm going to have not 10a, sorry, 8a, right? Yeah, 8a plus b over 3 and c. And now you know they're in business and you go like, hey, okay, I think this is lame. Actually, it's really lame and easy. Okay, now here comes the next part. And this is the part that many students tend to get it wrong. Okay, again, they're being hasty, they're being careless, but that's all. All right, another 9 centimeters is covered in the next 7 seconds. So you're already at 8. The next 7 seconds talking about t equals to 15. Okay, so we're talking about t equals to 15. All right, and another 9 centimeters. So that means y must be equal to 19 now. Okay, so you'll be surprised by how some people can get this wrong. Okay, they'll put y equal to 9 or whatnot. Okay, so the whole idea is people can get careless. Okay, so you do want to be a little bit careful. So 19 is equal to 15a, and then 15 plus 1 is 16. 16 square root is 4 plus c. So you have three equations, three unknown. Please tell me you know how to solve this. All right, so you're going to say by GC. Okay, so you're going to go punch inside of GC the three equations. Now I can't see my equations. Hold on, let me push this here. Okay, all right. So put in the equation 0. I'm quite sure you know how to key all this yourself, right? So perhaps I don't have to show you this. Okay. See. Sorry, my GC is a bit laggy today. I also don't know why, but never mind. All right, but anyway, after you key in the GC, I know the answer already. Okay, so you're going to get A is equal to 31 over 24. Okay, and B is equal to half, and C is equal to minus half. Now, to be really honest, okay, this answer, or rather this set of answers, doesn't quite inspire confidence in exams. Agree or not? If I were to have this answer in exam, I'd probably press my calculator 2 times just to double check. Okay, just to make sure I didn't key in something wrongly. Okay, it's because usually we expect nice number, but turns out that this is really it. Right, but of course that's not the end of the story. After we found ABC, we are supposed to try to solve the problem. Okay, so solve the problem meaning to say, answer the question. All right, so the question actually asks you for the distance traveled how long when t is equal to 24. So that's what you need to do. Okay, so put in t equals to 24. All right, and you're supposed to get your y, and you will get 30.6 cm. Are we good? Okay, any questions up to here? Quick. All right, this is easy. Okay, this is easy. I'm not expecting a lot of questions or a lot of doubts. Okay, no problem. Okay, no problem. Then let's move on. All right. Hold on. Let me close this. It may be taking up too much resources and it's causing it to be quite laggy. Okay, next one. All right. Summation. Okay, now this one does pose a bit of a challenge. Okay. Well, probably just a bit. Okay. Oh, you can hear me loud and clear, right? Because it seems to me that the computer is a little bit laggy. I don't know why. Was it the network or is it something else? I'm trying to find out along the way as well. Okay. So no issues. If you got issues, just let me know. Okay. All right. If no issues, then I think I should just continue then. Okay. This is summation. All right. As you probably can imagine. All right. Like I was just teaching my J1s. Okay. Usually there are 3 ways to solve a summation problem. All right. APGP, method of difference, or some magic formula. Okay. So in this question, you notice that there's a 2 mark, 3 mark, 2 mark. All right. And pretty obvious is to show this. This gives you a hint that you are probably staring at something called method of difference, right? Because of, well, something like this and minus each other and stuff like that. Okay. So but let's get past the 2 marks first. Now trust me, okay, this 2 marks is actually not the easiest 2 marks in the whole set of paper. Okay. Reason is, okay, now it seems easy enough, right? That okay, UR is just 1 over R factorial. Okay. And of course UR plus 1 will be simply 1 over R plus 1 factorial. Now I think everybody knows that. So then you say UR minus UR plus 1 is going to be 1 over R factorial minus away this R plus 1 factorial. Now, it is not difficult to understand that you need to, all right, make this look like this. Agree? Okay. So pretty obvious is you need to make common denominator. Yeah, just join them up together, stuff like that. Okay. But you also notice that if you were to just, just do it by brute force, and you probably get the denominator that looks like this. Now, even though the denominator like this, called common denominator, it is not wrong, okay? But you probably guess they're gonna have a hard time trying to make it look like this ever, okay? Because of you see, you already started on the wrong footing, and I don't know how you can get out of this, Okay, so I guess some of you will get stuck if you were to do it this way. Now, the more efficient way, all right, is to remind yourself that you are dealing with a factorial. And you better remember, or you better know that 5 factorial is actually 5 times 4 factorial. And therefore, you probably should understand that your r plus 1 factorial is actually the r factorial times another r plus 1, and that's it. Okay, so it is not that different, right? You want to understand that these two denominators, even though they look different, they are not that different. So actually, all I need to do is to multiply r plus 1 to this fraction, and I will have common denominator already. Agree? And guess what? The numerator is surprisingly simple. Okay? All right, surprisingly simple. Now, it is not that you immediately get the answer, because if you can, well, if you take a look at the answer, you're still quite far away. But trust me, okay, this is probably one big step towards the answer. Okay, one big step, but it's not quite there yet, lah. Of course, you can tell, right? So the next thing is, okay, great. Now, what am I gonna do next? Now what? It's like, I need a 1. Pretty obvious. I need a 1 up there. The only way you can get the 1 is to make sure that r can cancel away. Correct? The r can cancel away the top and the bottom. So you say, Mr. Ang, where is the 1? Where's the r at the bottom? How do I cancel away? Well, that's your own imagination already, and this is why you deserve 1 more mark. Okay? If you did something like this, r plus 1 factorial is literally r minus 1 times r. No, sorry, r minus 1 factorial times r plus 1. Okay, do you agree? All right, say yes. Okay, it's not that hard to understand, right? That is how you probably can guess that I can cancel this away very nicely, and I get my 1. Okay, that's nice, but you still don't get your answer. All right, you get the numerator correct, but the denominator is wrong, right? The denominator is well, not quite there yet. So how are we going to get there? Now, this is where the part that I would say is not easy to tell. Okay, so what I'm going to do is this. Okay, imagine this is 1 term, and these are like 2 terms. So what I'm going to do is you're going to multiply in. Okay, so when you multiply in like that, you notice that when you take r minus 1 factorial times r, that's going to give you r factorial, and then times 1, that's going to give you r minus 1 factorial, and that's how you show. Okay, for 2 marks. Actually, this question in the actual exam that I took it from, it was only 1 mark. Okay, but I added 1 more mark because I think 1 mark is a little bit stingy. Okay, so 1 more mark just to make it a round number. The whole paper has a round number anyway, right? Okay, so the 2 marks, I will say that if you get to here, you deserve 1 mark. Okay, all right, at least you do the what is it called, single denominator, right, correctly. And of course, final answer from the journey from here to here, this 1 mark. This 1 mark is the hardest to get. Okay, all right, not easy. So far so good. Okay, then we move on. Now usually what many students will do is, of course, if you cannot show, it's fine, you know. All right, doesn't mean you get 0 for the rest of the question. All right, you cannot show, never mind, you just use the answer and do it. Okay, at least you can still secure the next 5 marks. Are we good? Okay, let's move on to the hence part. Now, as you can probably imagine, it's called hence for a reason, because let's say you are very clever and then you have a thing for this kind of thing, right? And you can solve it in 3 steps, you get 0. Okay, because you're supposed to use the hence part. All right, so hence part meaning to say, well, somehow you better be able to see the relationship between what you are trying to do now, or rather what you're trying to sum up now, and what you have just shown up there. Okay, so of course, pretty obvious is that, well, it must be related. Problem is, how are they related? Okay, so if you stare long enough, you probably can see that I know already, Mr. Ang. Actually, this is just the sum of this. Agree? Right? When r is equal to 3 to n, to big N. Do you think it makes sense? Yeah. Agree? I mean, you can tell, right? Pretty obvious. We put in 3, we put, and so on and so forth, right? And actually, the last term actually is a big telltale sign. Come on, look at this. They are exactly the same. Okay, so the last term usually give you a hint of how the summation look like. So there you go. So then, of course, please do not forget that, hey, wait a minute. If this is yellow, this is yellow, and therefore this is still yellow. Okay, therefore the sum of this yellow part is the same as the sum of this yellow part. And well, pretty obvious, you're going to get u3 minus u4, u4 minus u5, and so on until your u big N minus away your u big M plus 1. Add all together, all right, cancel everything. You're going to get u3 minus away um plus 1. All right, that should be the answer, but hold it. So you have to write something like this. Therefore, okay, final answer. All right, equals to u3 must be 1 over 3 factorial, right, which is 1 over 6. Okay, that's pretty easy. And then minus away m plus 1 factorial. Done. Okay, so pretty easy, right? I hope you do have a sense that it's okay. All right, now how do you give your 3 marks like this? All right, first of all, it's the relation. All right, so it's a hence question, right? So being able to relate to what you have done before deserve that 1 mark. The method of difference process and getting this answer, all right, deserve that 1 mark too. And the final answer deserve 1 mark. Again, 3 marks. It's a lot, right? A lot to give, okay? So they are being overly generous here as well. Okay, so let's move on to the last 2 marks. Deduce that this is less than 1/6. Okay, how do you deduce this? Now, so some of you may say, Mr. Hold on. I know. Okay, look at this. Okay, hold on. Didn't I just show that this is equal to this? Yes, you did. So if this sum is equal to 1/6 minus away this, and this is confirm a positive number, correct? So 1/6 minus away some number is definitely less than 1/6, and that logic is correct too. Now, which means what you have just discovered is the fact that, well, whatever this sum may be, whatever n may be, the big N may be, it is always less than 1/6. That's true. But that's not the question, what? Notice? So you're telling me this is less than 1/6, so what? I don't care. I want to know this. So now this is the part that you got to scratch your head. All right, and it's 2 marks for a reason. Otherwise, asking you to tell me what I just told you, that this nonsense is less than 1/6 is probably just 1 mark. It's pretty obvious it's less than 1/6. 1/6 minus something, confirm less than 1/6, correct? Okay, so there you go. All right, so how on earth are we going to try to relate to what we found out to this question? All right, so again, no space, okay, so let me try to copy this down so that we don't have to do the scrolling up and down. Later, we'll all get seasick and vomit. Okay, all right, let's just put it here. Nice. Okay, so there you go. The information that we knew is the black color one, and I'm going to deduce this. Okay, so how do I start? How do I do that? Well, you also should take note that the biggest difference is actually just this joker. Agree on? Just this fella that's being different. Everything else is the same, right? There's an R, there's a 1 over, the lower limit, upper limit are all the same. How do you start? Okay, so the how do you start part is going to be the part that you want to learn. Okay, the part that you want to be exposed to. Well, the idea is this. You better know R plus 2 is more than R minus 1. I need the R minus 1, right? Yeah. Please tell me you know, okay? Of course, R being integer, okay? Because R must be positive integer, right? Because R is a running number. In fact, R is from 3 to n, okay? So I don't think you need to tell people, okay? So this is fine, I'll confirm, we all understand that. And therefore, you probably understand that, well, if this is a bigger number, if I go and factorial it, will be more than this factorial, which is, well, make a lot of sense too, right? Now, if I add R factorial both sides, R factorial, by the way, is a fixed number. So if I add both sides, the inequality should still hold. Am I right? Say yes. Yes. Okay, good. Now, and since this is positive and this is also positive, I can do what I call reciprocate both sides. All right. In other words, I flip both sides. But when I flip both sides, I got to change the sign. Correct? Okay. Now here comes the funny part, or rather, here comes the important part. This fraction is less than this fraction. Agree? All right. Now, and therefore, if I change it into a series and I sum it up, this sum must be less than that sum. Makes a lot of sense. And guess what? I'm going to put R must be equal to 3 to big N, right? Cool? Okay. Now, this is when you start to think and go like, hey, wait a minute, this fella looks familiar, and you are absolutely right. Okay, so that fella is the fella that you got earlier. So now you know that this sum, which is what the question wants you to figure out, okay, is actually less than 1/6 minus this nonsense. That's how you show. Okay, and since 1 over 1 plus 1 and whatever this thing is more than 0, okay, you just have to write since it's more than 0 because it's understood, right? Nobody else will prove. Okay, therefore 1 minus 6 must be less than 1 over 6, like seriously. Okay, so you have a since final therefore. Okay, now I'm being very elaborate here in my workings, okay, and that's because when you go for exams, you do want to have clear statements or clear steps, all right, that your teacher will understand what you are thinking. Okay, that's important because you want to score, you want to optimize your working for scoring, okay, not just to do fast, but you want to score. Okay, you can do very fast, but nobody understands, you get 0 anyway. Are we all clear? Okay, any questions, anyone? This only how many marks? Two marks only, right? Okay, so the 2 marks, how do you give yourself these 2 marks? Of course, the reasoning, okay, the reasoning must be correct. Okay, the reasoning, that means to say, oh, why is it less than 1/6 eventually? That's because this is a positive number and so on, right? So this reasoning must be correct. The hard 1 mark to get is this: how do you relate this to this with an inequality sign? Yeah, that's the hard part. All right, and which is this step here lah. No, this first 2-3 steps. Are we clear? All right. So if you display some sort of something like that, some exploration of this, I think you deserve that 1 mark. Okay, even though you can't do the rest at the bottom. Okay. All right. All of you are being very quiet. I suspect it's simply because it is not hard. Okay, and therefore you can understand this. All right. And by the way, students who are in my class, you should know that you don't have to copy everything, because you will have this everything that I wrote down in your notebook automatically anyway, right? So you don't have to copy, it's all there. All right, anyways, now this is an interesting one. This is a hard question as well. Okay, this one definitely deserves our time and deserves our attention. Okay, first of all, it's hyperbola. All right, and hyperbola itself is quite challenging for some students. Like you ask some J2, they draw, they also struggle. Then they tell you they use GC. Okay, and I've been telling my students all this while, the GC doesn't help you draw hyperbola at all. It is completely useless. All right, so you want to know a hyperbola a little bit better. All right, so this is a hyperbola question, but turns out this is worse than those just drawing questions, because actually they're not asking you to draw. You notice, right? They only tell you it's hyperbola. So some people see this word only, they freeze. They go like, shucks. You know, skip first, come back later. But they will not come back on because no time already, right? Okay, so this is a hyperbola equation. And first of all, the equation looks weird because we all thought that, wait a minute, I thought hyperbola looks like this. Like something like that, right? Or is x squared minus y squared or y squared minus x squared, whichever the version, but it doesn't matter, right? It looks weird. Okay, so you probably understand that this is the version that is expanded. Okay, so the question is expanded for you, and then you're supposed to draw. All right, so A, B, C, D are real constants. Okay, passes through the points and has a maximum point, and it's given that this is a asymptote. Wow, great. Now what I can do? Now you probably guess that if I'm trying to find A, B, C, D, I need to probably form 4 equations, and there you go. You're at some simultaneous equation question again. Okay, which means there are 4 equations, 4 unknown. Try to solve something like that. But first thing, I need to form the equations. So you say, not that bad, because if you substitute these values or this point in, right, that's your x and the y. So you're going to put in y equal to 17. This is b, correct? Agree? You got 1 equation. For a moment, you probably have a sense of relief, and you go like, hey, not that bad lah. Not that bad. Okay, we try. Let me simplify. Okay, so we're going to get 25 over 9b, and then plus 5 over 3c plus d is equal to this negative 17 square. Okay, I'm not that clever. I mean, I just have the answer. Okay, so it's a negative 289. There you go. Okay, first equation. So it sounds easy. Okay, of course you take a look at this and go like, hey, you know what? That point is on the curve, right? So I'm going to substitute that point too. That makes a lot of sense. Okay, so I'm going to substitute in minus 1, 1, which I'm going to get pretty easy stuff, plus, and then plus b minus c plus d is equal to 0. So we probably just bring the 1 over, and we're going to get this, right? So I got 2 equations already. That's nice. Here comes the problem. How to find the third? That's not easy. Okay? Now, how do you find the fourth? I mean, you can't even find the third, you forget about the fourth. Okay? So, in fact, there are 3 more ways for you to find the equation. Okay? Now, again, I suspect that most of you are J1s. So, some of you haven't learned implicit differentiation. So, I will leave that out for a moment. Okay? But I'll show you implicit differentiation shortly. Okay, so those of you who know implicit differentiation, you know that that's one of the ways already, all right, to form another equation. All right, so let's say we don't know implicit differentiation. We really don't know. I haven't learned implicit differentiation. Can I do this? Of course you can, all right? So pay close attention, okay? So what's going on is this. Now, the maximum point is at minus 1, 1. You know what that tells you? It tells you that your hyperbola looks like this. Okay? I mean, there are 2 types of hyperbola, I better know, right? The up and down version, the left and right version. Okay, so you don't need to go to a GC and try to find out, but the question actually told you, right? Maximum point. So you know that there is a maximum point at what is this called? Minus 1, 1, correct? Now, also you better know that it being a hyperbola, which is conics and all, they are perfectly symmetrical everywhere. In other words, this minimum point will be on minus 1 something too. Now, and if you can figure out why is this something, you got another point. And this other point will allow you to find another equation. So that becomes your third equation. Now, then you say, Mr. I know that, but you know what? I can't find this point, right? This is at minus 1 question mark. Yeah, great. What is that question mark? All right. Now, this is when you want to be a bit more into your conics one more time. Okay, they did give you something about the oblique asymptote. And now you know what's the oblique asymptote? Now, for your hyperbola to look like this, there must be crisscrossing asymptotes like this, right? Okay, crisscross. Okay, now the 2 oblique asymptotes will meet at what we call the center of the hyperbola, right? And the center of the hyperbola must be again the symmetrical point, right? Now you see they are symmetrical like that. Okay, if you were to draw the symmetry, it would be like this. So of course my drawing sucks. Let me try again. Okay, I should be directly. The 3 points must be collinear lah. Okay, can you see that? Okay, great. So it's Mr. So what, right? Pay attention. This is what I need to know. All right. Now you better know that this being the center of the hyperbola, you'll be equal distance away from the 2 vertices. Okay, meaning to say this, it'll be equal to this. Makes sense, right? Otherwise, how to be symmetrical? Correct or not? To be symmetrical, it must be equal size. Equal size, equal gap. What? So in other words, pay attention. You know that this is y equals to 3x plus 10. You know the equation of the asymptote. And if you know the x, which is at minus 1, I'm sure you know the y, right? It's going to be at minus 1, comma, 6. No, not 6, 7. My bad. 10 minus 3 is 6. Okay, 10 minus 3 is 7. Agree? So that point there is going to be minus 1, 7. Now it's a bit tiny. Maybe you can't see that well. So let me blow it up big for you to see. Can you see bigger now? Okay, now I know what's the big thing. What's the big deal about this? Pay close attention, okay? You know that this is at 1. This is at 7. This gap is 6. If you know that this gap is 6, this gap has to be 6. And therefore, this point, this question mark that I drew up here has to be 7 plus 6, which is 13. You got your third point. Do you understand? This is purely using the property of your hyperbola only. And then nobody asks you to draw. But I mean, I have to draw because I have to show you how I figure out the gap 6 and all. I mean, how do I even figure out this point? Correct? So if I don't draw, I think it'll be very confusing for you. So I have to draw, and now you have this 1 point, which you're going to substitute in minus 1, 13, and you're going to get a third equation. Awesome, isn't it? Plus b minus c plus d is equal to 0. So you have a third equation, 13a plus b minus c plus d is equal to negative 169. I need one more only. Agree? Just one more. Okay, again, I'm not going to do implicit differentiation because some of the J1s haven't learned implicit differentiation, so that will not fair, right? Now, of course, if you know how to do different implicit differentiation, you already can figure out one more point already, or rather one more equation already, right? But let me hold it. I'll show you later, but I want to go through it without the differentiation, okay? Meaning to say, how am I going to find the last equation so that I can find these four unknowns? All right, without using differentiation. All right, so again, this one probably a bit longer, a bit harder. Now, what you want to understand is this. Now, a hyperbola looks a bit like this. Now, you don't really have to memorize this because, believe it or not, your GC actually is helpful for this hyperbola. And the only thing that is helpful for is to, okay, go to apps, you have this conics, right? And then go to hyperbola, which is number 3, correct? It's actually this screen here. This screen I find the most useful, okay? Because you can tell that if you're looking for the up and down version, which is the red color one, I don't know whether is it too small for you, this red color one, okay? It is the y squared minus x squared, okay? If you have the x squared minus y squared, it'll be the left and right. Okay, cool, right? That's what this app is useful for, really. So we know that this equation is the same as this. Okay, we know that, okay, so you go like, okay, but of course, they look so different because some joker got nothing better to do, go and expand, simplify, and that's why it become like that. Now, of course, you can now do the same. Now, of course, the other thing that you do want to know is that when you have your hyperbola equation in this format, the denominator actually will give you the gradient of the oblique asymptotes. Okay, meaning to say, if you take A over B, that will be your M, or actually plus minus. Okay, so in other words, A over B is 3. Or actually plus minus 3 lah, because there's another one, right? There are 2 asymptotes, right? This is 3, this will be minus 3. Okay, so the A over B, or if you like, the number below the Y over the number below the X. Okay, you can memorize, really. This is one of the things that you want to memorize. Okay, so A over B equal plus minus 3, all right? So that's one thing we already know, but that doesn't help because, Mr. Ang, there's no little a, little b there. I don't know what is this for. True enough, right? I also don't know what is this for. But you know what? We are trying very hard to find one more formula or one more equation, correct? So you probably guess that you may want to make these look like this and you do some comparison. That sounds like a good idea. Okay, so that's precisely what I'm going to do. B squared y minus h a squared x minus k over a squared b squared equals to 1. Cross multiply, this will be equal to a squared b squared. Now, I'm not going to expand every single thing. Not important. But one thing that is very, very telling is inside here, in this expansion, if you go and expand, but nobody will do anyway, you're going to get y squared. There is a y squared. Inside this expansion, there is an x squared. There is an x squared. Okay? Yeah. So, but like I said, nobody's going to do the expansion like mad because not worth it, not worth the time. So you just need to know that, okay, guys, I will have a b squared plus y squared plus dot, dot, dot. I don't care what the rest are. I have a minus a squared x squared. Again, I don't care what the rest. But these are the important stuff. These are the important stuff because this must be this, correct? And this, use another color, okay? This must be this. Oh, great, green on green. And not bad, green on green still look quite nice. Okay, yeah. Okay, and you compare, right? If you can compare like that, you probably can guess that, hey, wait a minute, I know my b squared must be 1, and I know that my minus a squared must be equal to b, correct? And therefore a squared is equal to minus b. Okay, whatever lah. That already tell you one thing, that this b must be a negative number. Otherwise, how does it make sense, right? Okay, so it must be a negative number. So you say, Mr. Okay, so what? I'm still a bit stuck. Well, because we found something here up here just now, right? That your a over b can be equal to 3 or negative 3 for that matter. Okay, but just keep it to 3 first. We do another one. You know what? Let's just do the other one as well. This is not relevant, but never mind. Okay, so if I know that a over b is equal to 3 because of the gradient thingy, right? I told you. then straight away you should know that A because B is equal to 1, right? So you will know that your A must be equal to 3. Correct? Or A is equal to minus 3. I mean, come on. Okay, either way lah. Okay. So once you got the A, then of course then you realize that your A square, which is 9, is equal to minus B. And therefore your B is equal to minus 9. Ta-da! Again, you see, regardless of which one you substitute in, you get the same number. You get the same answer for your B. Big B, sorry. I should use big B, right? Otherwise there's a small b, big B, you get confused. You get the point? You solve for 1 already. Therefore, you got this, you got this, you got this. And then you can find your ABC. Nope, A, C, D. Okay? Right, it's like a domino, right? One down, all down. All right. So let me show you quickly. All right. So first equation, your first equation is this one, right? This one up here, correct? Okay. So let me write it down for you. All right. The first equation is now going to look like this: 17a minus 25 now, because b is 9, correct? Or rather negative 9. Then you're going to get plus 5 over 3c plus d is equal to minus 289. Okay, so that becomes your first equation. Of course, I believe you can simplify that one, which will then become minus 264. Okay, so that will be my equation 1. And my equation 2 is this one, right? So just bring across lah. Very easy. Okay, minus 1 plus 9, so that's going to give you 8. That's your equation 2. Okay, and lastly, your equation 3, 13a minus c plus d is equal to minus 1 plus 9, so that's minus 160, right? There you go. You solve your problem. You got your big A, big B, big C. Turns out, again, I'm not going to show you pressing calculator. I think that will take up like easily 10 seconds. So we want to save every seconds that we have, okay? Because I have this funny feeling that we're going to overrun again. All right. So we got the ABC. Once you got the ABC, we solve our problem. A, B, C, D, actually. Okay, so there are 4 equations for you to form, and there are 4 marks for you to grab. Okay, so I believe each of the equation deserve 1 mark. And therefore, the final answer actually no mark. But anyway, final answer is just using calculator. But of course, if your final answer is wrong, you won't get full marks anyway, right? So depends on how generous, right? Probably this one doesn't even deserve 1 mark, so the 1 mark goes to the answer actually. Okay, so you have 4 equations, right? You only have 4 marks to give, so probably the easiest equation doesn't deserve the mark. Okay, so these are the 4 different equations and how I got them. Okay, so the light blue color part is something unique. All right, the green color part is something to do with hyperbola equation, all right, as well. So there's actually another version, all right, another way you can get another equation that is called implicit differentiation, because we all know that it has a maximum point at this, which means that you can actually differentiate, and you get 0 when you substitute in x equal to minus 1, y equal to 1. All right, so the differentiation is not that difficult, again, because this scrolling thing is not very efficient. And okay, so I'm probably just going to copy this, paste it here. All right, and then we can just see it from here. Okay, so you can differentiate this. You're going to get 2y dy dx plus a dy dx plus 2b x plus c equals to 0. So minus 1, 1, put inside. Anyway, okay, you probably want to explain yourself better. Dy dx is equal to 0. So this will be 0 plus minus 2b. Okay, nobody write like that. Plus c is equal to 0. So there you go. Okay, so instead of forming this equation, you could have formed this. Or either one. Basically, I gave you 5 different ways to get the equations. Okay, 5. You just have to choose 4. Of course, you choose the easiest 4. All right, the easiest 2 will be the first 2 that we did, right? These are the easiest, and then the rest are the ones that you have to think a little bit harder. Okay, so of course, those of you who know implicit differentiation, you'll probably guess that implicit differentiation is the way to go. All right, but for J1s, by the way, this is an exam paper for J1. exam anyway, right? So we have to assume that the setter has intention to test the student more on hyperbola. Okay? Any questions? Okay, again, very quiet, no question. No question. I'm going to assume the best. Okay, and assuming the best means you don't have any question because you understand everything. Okay, let's move on. This one, okay, called transformation, right? Pretty obvious when you see a graph inside the question, that's the transformation. The diagram is a bit too big, so I won't have space to do anything else. Okay, so 4 marks. Okay, so I saw some of those who handed in the work. Sorry, my students in my class will get to hand in and I actually check for them. Okay, so I actually mark for them. Most people get it right so far. So that's awesome, right? It's 4 marks. I would say it's a pretty easy 4 marks. Okay, so you just have to know what will happen to the graph and so on. So let me go through quickly because this is one of the easiest one today. Okay, so what you're going to do is this, right? We follow the AMA rule, add, multiply, multiply, add. Okay, so fx, we're going to do fx minus 1 first. Then we're going to do the multiply. Most of the schools, I would say, probably almost every school will teach you this way. All right, you do the adding first, which means translate first, then you scale. In this case, it's not really scaling. All right, it's negative, which is a negative scaling, which is reflection. Okay, anyways, yeah, we always do the translation first, that sort of things, right? Different school teach you different ways to memorize. So I taught my students ama versus mama. Okay, so I think when I say ama, everybody knows what I meant, right? Add, multiply, multiply, add. So what you need to know is very, very importantly, this transformation or this series of transformation, these two things that happen here will never affect the y values. Simple as that. All the y coordinates will remain exactly the same. Will remain exactly the same. Hold on, I just realized that there's a A, there's a B, and there's a C, right? So I probably should transfer down the points. Otherwise, I get very lost inside. What's point A? Point A is 0, minus 2. Okay, let me just write side by side, okay? Point B is minus 1, 0. And point C is, where's my point C? 4, half. There you go. Okay, so yeah, so we don't have to keep on scrolling up and down. It's making me giddy. One thing, what I was saying halfway, right, that this kind of transformation, anything that happened inside the bracket will only affect the x coordinate. You better know, all right? Anything that happened outside the bracket affects the y coordinates. So in this transformation, you better know that the y coordinate is never going to change. Nothing will change. For example, this will not change. It will still be there. So you should put it in first, right? Y equals 3. In fact, all the y coordinates will not move. They will not move. Okay, so you got to be very confident about that. They will not change. What will change? All the x will change. How will they change, right? Okay, so let's do one at a time. Okay, there are 3 things to move. First, we move the asymptote, which is x. Pretty obvious, right? X. So you better know what does this do. Now, this is a translation. Minus 1 means you move forward by 1 unit. So the x equal to 1 will become x equal to 2. You move forward, okay, by 1 unit. And then what does this do? Well, it reflects over, so it becomes minus 2. So you just have to have this mentality that this is exactly what you're going to do for every single x there. You're going to move forward by 1 and you're going to flip it over to the other side. Done, okay? So 1 becomes 2, 2 becomes minus 2. So there you go. My new vertical asymptote is going to be here. That's x equals to negative 2. All right, and let's start moving the point A, shall we? So the point A is at 0, okay? So if you just follow, I'm going to just follow my arrows, huh? All right, move 1 becomes 1, 1 move over become minus 1. So you have 1 point already. That's like minus 1, minus 2. That's your A. That's the image of A. Got no space. Minus 1, minus 2. Okay, there you go. All right, image of B will be at origin, pretty obvious, because when at minus 1, you move forward by 1, you get to 0, 0. No matter how you flip, you still get 0. So there's your B. At that C is at 4, right? Okay, so 4 move forward, become 5. 5 flip over, become minus 5. Minus 5, half. Somewhere here. Now, guess what, guys? You just got all the coordinates correct already. Now, of course, this is not the end of it. You don't have any curve. What is that hanging? So you better jolly well know that This is a reflection. So don't please go and draw another exactly looking the same. I don't know how you're going to draw exactly looking the same. It can't look the same anymore. So you better have an impression that this L is going to look like this now. Okay, and this L is going to look like this now. Sorry for the vandalism, but I think you get the point, yes? The L is going to look like this. The L is going to look like that. Okay? So of course the point that C, there is a minimum point, it will still remain a minimum point. All right, so there you go. You just have to connect the dots. Sorry, a bit ugly. That one doesn't make sense. Okay, hold on one more time. Okay, not bad. Quite nice. I'm quite impressed by myself. Not bad. Miss. Okay, never mind. I make a bigger dot. Make sure you pass through origin. Okay, well done. Now, how do you deserve 4 marks for this? Hey guys, 4 marks is a lot, no? Okay, seriously a lot. I mark, I also don't know how to give the 4 marks. Okay, pretty obvious. Getting the point A correct. All these 1 mark, right? Because they say indicating the corresponding point ABC. So if you give the ABC correct, I'm sure you have some marks. Then now I got 2 more things, which is asymptotes. I only have 1 mark left. Okay, so of course the 2 asymptote correct, 1 mark. Okay, must be both correct. Either one wrong, 0, no mark already. All right, you don't have the 1 mark. Are you following? Of course, labeling, please. Okay, but labeling, this one will come under the presentation marks at the end of the whole paper, you know, Okay, so you don't want to get penalized for that. Are we good? Done. Okay, pretty easy, right? If you know a transformation well, this is lame. Okay, this question can be done in seconds. All right, the next one, which is the reciprocal curve. Again, a lot of people complain about reciprocal curve because they think that this is one of the hardest thing to do. Okay, not true. All right, because if you know the 4 steps involved, you just have to follow the 4 steps. You can't go that far wrong. All right, first thing first, you want to know that when you are trying to do this transformation called the reciprocal curve, all right, it only affects who? All the y values. All the x will not change. Meaning to say you expect this to still be the same. Done. Very, very simple. Okay, it will still be there. All the x coordinate will be there. All right, only all the y coordinate will be changed, which means that straight away you know this one will become 1/3. Okay, all right, it will not be so high anymore, it will be quite low. Okay, now I was saying about the 4 steps, right? So it's a revision test. So definitely revision means I need to neg again. I need to talk about that 4 steps and again, right? Okay, so step 1 is what I like to always say. Maximum point become minimum point when minimum point become maximum point. Okay, now not hard to understand, really not hard to understand. I mean, come on, when you have the biggest, okay, when you have the biggest value, when you do a 1 over, it becomes smallest, right? Very, very simple. Okay, so very straightforward. So do you have a minimum point and maximum point? Oh yeah, we do. There you go. So this point C, oh dear, I forgot to transfer the values again. You see, hold on, let me just transfer the information down. Okay, good. All right, now we have all the necessary information. Okay, so the point C is a minimum point, right? It's a happy face. So you know that it's now going to be a sad face. Okay, and the sad face is going to be at this point called 4, 2. Are we good? You got 1 mark already. Because getting the A, B, C correct is 1 mark each, right? Yeah, there you go, 1 mark. And it's a maximum point. All right, okay, step 2. Step 2 says that the vertical asymptote becomes the new x-intercept. And the x-intercept becomes the new vertical asymptote. Okay? Now, if you don't know why, never mind, I just memorize. I'll try to tell you, okay? I'll try to tell you, at least it makes sense. I help you understand this better. Now, take a look at point B, guys. Point B, all right? You know what it means at point B, right? At point B, when x is equal to -1, y is equal to 0. That's exactly what point B is about. Now, when you do a 1 over y, right? What happened? It becomes 1 over 0. 1 over 6. 1 over 0. Am I right? And that becomes undefined. In other words, when you do a transformation into this curve, at this point is not undefined. No such point anymore, which means that when x is -1, it is an asymptote. That is why your x-intercept become a vertical asymptote and vice versa. Okay, and the vice versa y, you also can go and make sense one lah. Think about it lah. Okay, so why is it asymptote? Well, it is probably because when x equal to 1, you get something like that, right? That's why it's undefined. It becomes asymptote. So when you do the flip, it becomes 0. Okay, so it's not that hard to really understand why this step, what this step is about. But you just have to remember and memorize. If you don't understand, you memorize. That get you somewhere too. Okay, you can get A also. But the idea is, of course, I want you to memorize it with a bit more understanding. So when people ask you why, you can at least answer. Okay, so anyway, my point is, I have a new asymptote here. Very quickly, right? And in fact, all these things can be done in seconds or no. All right, I'm taking a bit too long, right? But again, I'm trying my best to revise with you. At the same time, I'm trying to make you understand. Okay, not just do, right? Like I said, I don't do is like I'm the only one improving. Okay, step 2 done, right? Okay, let's talk about step 3. Okay, step 3 says quite simple stuff. All the y becomes 1 over y. Which is like, duh, I know that. Okay, all the y become 1 over y. Okay, so which means the y asymptote, which is at the half, is now at, 3 is now at 1/3. You better, okay, now this is what some people blur on. They see that this dotted line is above the point C, correct? Then they will go and draw this dotted line above the point C. Then they call this y equal to 1/3. Okay, now think, guys, this is 1/3, this is 2. How can the 2 be below 1/3? Seriously? Okay, so you better understand this as well. When things are above, when you do the flip, it becomes below. All right, when things are below, when you do the flip, it becomes above. We flip lah. Okay, get it? Flip. All right, so 1/3 is pretty obvious, less than 2, so you better jolly well draw a 1/3 a bit lower than that point C. That's 1/3. Okay, what other y values you see? There. That's it. That's the y-intercept. So you know that there's going to be a y-intercept called half or negative half actually. So somehow it's gonna cut here. I don't know where exactly, but you know what? I'm not gonna draw first, because if I'm gonna plot the point first, then I'm gonna have a hard time trying to link them up later, right? So I'm not gonna do that to myself. I'm gonna draw the curve first, then I label it later. Okay, but I know that there's gonna be a half. Okay. And good luck drawing. Come on, guys. Okay. See, sometimes we can have some smart guesses, like how do you think the curve will look like? I mean, come on, there's a asymptote here. It must pass through this point. It must pass through a half. You probably can guess that it must, okay? It must look like this and go all the way down. This is very ugly. Sorry, I'm a little bit of a OCD here. Okay, but okay. This is much nicer. So this one is a bad point. Okay, here we go. All right. This is the minus half. Okay, you can do what I call smart guessing. Okay, smart guessing in the sense that you guess lah. I mean, come on, this is a vertical asymptote. Vertical asymptote cannot cross over, right? So then you must pass through this point, must pass through that point. How do you think the curve will look like? There's only one way. It looks like this. Okay, now here comes the problem. How do you draw the rest? Okay, what do you mean by how to draw it? Pay attention. You see, there's a turning point here, right? Okay, you have two options. One is to like this, but the other one is like this. How do you know which is correct? Now, you don't say, Mr. Ang, wait, there's a horizontal asymptote. I know, there's a horizontal asymptote, but you must understand that horizontal asymptote is not like vertical asymptote. Vertical asymptote is very strictly enforced, meaning to say, if there's a vertical asymptote, no curve will ever cut across. Simple as that, okay? But for horizontal asymptotes, the curve can cut across one. See? Can cut what? Then how do you know it doesn't cut there? Maybe the horizontal asymptote is for the curve this side? You understand what I'm trying to tell you? So please don't pay too much attention. No, that sounds wrong. Please don't think that horizontal asymptote is so sacred. Understand? Horizontal asymptote is a tendency, and therefore it can be violated. Vertical asymptote cannot be violated. Okay? Now you have a problem, because now I just drop you this bomb and you go like, great. So how? Am I supposed to know? Is it supposed to be hovering above, or now I'm supposed to cut across? We won't know exactly, and that's the whole problem, right? Okay, so that's why I say guessing is you only get you that far, all right? So you want to go beyond guessing, all right? You want to have your fourth step, all right? The fourth step is what I like to call the tendency test. Okay, now tendency test sounds weird, lah. Like what? Is it like I'm going to rent some room or something? Okay, anyway, tendency test is basically you want to test how the curve will behave if you do the flip. Okay, now what do I mean? Now pay close attention here. Take a look at this. All right, you know what this suggests? This suggests that, well, x tends to positive infinity, your y, original y, okay, will tend towards what we call 3 minus. Okay, now this is not 3 power negative, it's just called 3 minus. You know what is 3 minus? It means 2.99999, very close to 3, but just slightly below. As you can see, there is just hovering below the 3. Can you see that? Okay, so if you're uncomfortable with this, then forget it. Just put 2.99999, okay? All right, it's okay. It works. As long as it works, can already. Okay, but I want to train you to look more pro as well, right? Okay, not only you know how to do, you must look pro also. Okay, anyways. So when you do the 1 over, what do you think it becomes? Well, you don't know, right? I also don't know. That's why we use calculator. Okay? So you just go to your normal Casio calculator will do. All right? And you know what I do? You go in 1 divide by, don't go in 1 divide by 3, okay, please. That will be lame. 2.999999999, as many as you like, up to you. Then you see this. Okay, first of all, what the heck is this? All right, it is a number that's slightly more than 1/3. Okay, you may say, Mr. No, that's 1/3. No, that's 1/3. 1/3, the 3 doesn't stop. This one, the 3 actually stops. Okay, so you better know that 0.333 is actually more than 0.3333333 that doesn't stop. Okay, all right, so basically it is a number that is big, slightly above 1/3, which is here, which is why the curve will be like this. It will not cut down. No, it will be like this. Okay. Now a hack, if you like. Okay. Oh, Mr. This is too troublesome. All right. Is there a hack? Yes. Pay attention. Sometimes you'll hack one. The hack is this. If you see a curve that is below a horizontal asymptote, like this, below, and you do a flip, you become above, law. Really. It works on. Okay. So of course, you want to memorize, you memorize like that. So you see this part here, below, right? You know already it's going to be above. Confirm. Okay. And then if you know there's above, and you know that there's a vertical, there's a wall there already, right? That cannot go through the wall one. How do you think the curve will look like? Like this, no? How else? Drive up the wall. I cannot go through the wall. You go up the wall. Get it? So that helps you. But again, let's say you want to do the test, right? You want to do the testing. Nowadays we all must test, right? You take a look at this one, X tend to negative infinity. What happened to my y? My y actually tend to 2.99999, something like that, right? It's same rubbish. Okay, so don't need to test again, waste time. Okay, but you get the point. This is the curve. This is how it should look like. Okay, how we get the 4 marks? Come, pay close attention. How I would give my 4 marks. Okay, if I were to mark your paper. All right. First of all, the point A. Where's my point A? Oh yeah, there you go. That's my point A. That's the point A, right? Yeah. Point A becomes 0 minus half. All right, because they say the question did mention that you have to tell people the ABC, right? Yeah, so you better tell people the ABC label. Point A correct, like this. The point B becomes missing already, right? So no, don't have. Okay, and then the point C correct, 1 mark. The asymptote correct. Okay, both asymptote, I would say both asymptote, 1 mark only. Okay, all right. And of course, the shape itself. Because you can get everything correct, but the shape wrong. Okay, some joker will go and don't know, draw what funny shape like that. I don't know lah. Okay, maybe I should take some pictures, show you all next time. Okay, but my point is that the shape must be correct. Okay, so sometimes you get all the points correct, but the shape is completely opposite, rubbish. Okay, so then of course you won't get 1 mark at all. 4 marks. A, especially J1s, sure come out for exam, mid-year, common test, promo, because they got nothing else to test you already. Okay, unless you are in what school? I know some schools do this in J2 okay, I think RI, but RI this year a bit changed also. Never mind. Okay, so but my point is, you better be good at this. Okay, and it's actually easy. All right, with practice you can do this in seconds really. Okay, come chop. Next. See, my mouse doesn't work. No, not my mouse doesn't work. It's this one note. Okay, automatic. Give me a while. Yes. All right, 1, 2, 3, 4. Not too bad. I hope I won't eat into your time too much, okay? Because I know all of you are busy studying for your exams and whatnot. Now, this is APGP question. All right. To some people, it's nightmare. All right. Worse, this is a money problem. I don't know whether you know money problem or not. Okay, money problem is one of the biggest headache for APGP. One of the biggest headache, not the biggest. Huh? All right. Why I say that is because, well, I don't know whether you tried this again. If you tried enough APGP question, you should notice that when it comes to money, there's always two transactions, right? Someone put in money, take out money, put in money, take out money. Then the problem is the money you take out and then the money that goes in is different. All right, the pattern is different. Okay, that kind of thing. So anyway, shall we read this through quickly? CC, I mean community club, okay? Don't think as a person. CC initially starts with no member, poor thing. And the club charge a one-time membership fee of $80. So you want to join, you pay $80. Right, in the beginning of every year, 50 people take out the membership. Not bad, okay? Make payment, right? The club keeps all the money in the bank, which give an annual interest of 10% at the end of each year. Show that the amount of money in the bank at the end of each year is this. How to do? Okay, so you see, how I taught my student to handle money problem is to draw a table. Okay, and your table should have this few feature. Number one, you better have a counter. Okay, counter as in something to count, right? Year 1, year 2, year 3, then we call it N. Okay, then you better have a column called the start and another column called the end, the end or whatever lah. Okay, so that your table makes sense, you see, because you want to trace the yearly progress, and then you see the whole idea is to spot a pattern, so that you are able to show the money at the end of the end year. Means what you're trying to do is to get to here. Ta-da! This is your jackpot. Okay? And to get to there, you better jolly well understand the story. Because if you don't understand the story, you are dead from the start. Okay? So, year 1, what happened? Well, 50 people joined the member. But I don't care about the number of member, guys. I care about the money. I'm the bank. No, I'm not the bank. I mean, I'm in charge of counting the money, right? It's start of the month, start of the year, how much money I have, end of the year, how much money. So I better know how much money I have. So 50 people join, everyone pays $80. That's like $4,000 in the bank in the start of the year. This is not difficult. Primary school kid can do this. You better tell me you know, okay? And primary school kid can also do this. Wait, hold on. Do they learn percentage? Never mind. Okay, I assume they do. Nowadays, primary school kid very clever. Okay, so there you go. End of the year, you get 1.1 times 4,000. Cool. That's your first row. Yeah, very easy. Now let's move on to the second row. Now, second row is where things start to get a little bit haywire. Okay, so you're gonna have this amount of money in the bank going to the second year, like the money doesn't disappear. But guess what? More money is coming in because now you got another $4,000 coming in. Ta-da! That sounds like good news, right? Like ang pao money like that. Okay, then what's gonna happen? Well, at the end of the year, this whole amount is gonna earn a 10% interest, which means you're going to take 1.1 times this. Okay, in case you blur already, let me color for you. All right, okay, never mind. That's the same yellow part. Can you see that? Okay, say yes. Good. None of you say yes. Okay, but never mind. I'll say it myself. Okay, so then, again, now you're trying to spot pattern, right? Now, spot pattern meaning, please don't be a joke and go and work out this number. I say being a joke, okay, not being a joker, okay? So if you go and work out this number, you will never see the pattern because they're all like random number already. Understand? So don't go and work out this number. I'm just got a calculator. I know you have, I also have, but what's the point? You work out a number for what? Okay, but what you want to work out is a pattern. 1.1 square. Okay, leave it there. Don't go and work out the number. You know how some people like, oh, I know how much. For what? That number is completely useless and it's very distracting. Okay, because it makes it look so hard. All right, okay, anyway, that's my year 2. Usually, for money problem, by the time year 3, you better tell me you saw the pattern. Okay, because if you don't see the pattern, you are you're missing something lah, huh? Okay, you're surely missing something somewhere already. So this is the amount of money you carry forward, and then you're going to add another $4,000. And now this is the green color, and you're going to take 1.1 times this green color. What are you going to get? You're going to get 1.1 cube times that 4,000 plus the 1.1 square times the other 4,000 plus 1.1 times the other 4,000. That's your year 3. Now, the whole idea of being able to spot a pattern is that you don't have to go on. And that means to say you can figure this out. Okay, in mathematics, there's the term called extrapolate, but never mind. Okay, so you can actually use the pattern to extrapolate to get there without doing it like n times. Honestly, how to do n times, right? In fact, we do 10 times makes sense. The n time doesn't make sense. Okay, but my point is, can you see the pattern? Say yes. Okay. Now, you see, not hard, right? Not hard. You probably expect the pattern will continue forever because when this is 3, right, you're going to start with power 3, power 2, power 1. Hey, that's not too bad, right? 3, 2, 1. And guess what? There are 3 terms and they look all the same. Okay, so you can tell that that must be a GP, correct? And it's a GP with the common ratio of 1.1. Okay, whatever you want to call it. So basically, it's going to look like this. I'm going to, okay, never mind. I'm going to show it the other way around, okay? So 1.1 square. Okay, you get me? I'm writing it ascending order, okay? It used to be descending order and so on, right? Okay, so this will be, the last term will be 1.1 power n 4,000. Agree? Okay, there'll be n terms here, all right? Now, up to you. If you are very adventurous kind and then you say, Mr. Tang, this is your first term, go ahead. Okay, I won't stop you. But if you are like me, a little bit more conservative, then you say that, Mr. Tang, maybe I take out the 4,000 first. I would think this is a better idea. Okay, but anyway, no harm done one lah, to be honest. Okay. So the idea is that at least you don't have to write the 4,000 like 4,000 times, right? Okay. So you have 4,000 and then you have you better know the formula. You're going for exam, you know. And APGP formula is not in the formula list. You don't know okay? You better know okay? Because APGP is not in the formula list. Let me repeat. 1.1 minus 1 is 0.1. Okay, that's embarrassing to ask. Okay, and of course we simplify all this nonsense. Let me see. You better tell me you can do this. I have to use calculator myself. Okay, this is too difficult, right? This is too challenging. Oh, it's 11. I see. 8 times 4,000. Okay, I have no idea what this is. Oh, 44,000. There you go. We're done. Do we show it yet? Is it shown yet? Okay, sometimes the show can be quite annoying because it's in a very funky looking form that is not quite like my form. Turns out, yes. Okay, we're done. Okay, 3 marks. Now, it is not the 3 marks nor the answer that's important here. Understand? It is the strategy, the way that you want to do this kind of question all the time. Understand what I'm talking about? All right, so you learn this question, you don't just learn this question, you learn the method. You want to know, hey, it looks so easy now, what's going on? How come every time I do, I very lost one? That is because you're very lost, right? Because you never put in the columns properly. Okay, so be very mindful about this start point, end point, I mean, not start point, end point, the start column, and end of month, start of month, that kind of thing. Depending on the question, of course. Not all the questions are the same. Okay, but when it comes to money problem, more or less, this is a very good strategy. Okay, all right. Now, the 3 marks, how to give, right? Okay, I would think that if you have some sense of identifying the correct pattern, you deserve the 1 mark. That means whether you draw table or not is up to you. Okay, but trust me, I think table is the best way to present your answer, as well as it helps you check when you are having the time to check. You know, before exam end, right? Then you check. Then if you just write all over the place, I tell you, I don't know how you're going to check. Wrong also, you can't tell it's wrong. Okay, so you want to be able to check. I think a table is a great idea, and your teacher can immediately see where you went wrong. I mean, touch wood. What I mean is, your teacher can see, oh, you are so clever. Okay, you get the point? All right, so the pattern is very important. The table is a hack. All right, then of course the simplifying to get to the GP. I think writing down the GP formula, you deserve the 1 mark. But then again, giving you this 1 more mark is very lame, right? So I would say that sorting things out, getting here as well as here. Okay, that means sorting out the GP, then using the GP formula to get the answer. Okay, all these steps deserve that 2 marks. Okay, any questions? Should not have. Let's move on. Okay, you see, I'm like questioning myself and answering myself like that, all the time like this. Soon I'm going crazy. I'm talking to myself. Okay, so but you're being very quiet, I suspect, because you really have no question, and because I also be very paranoid over time. Okay, because I used to I always overrun one. Okay, so the club closes down, voting, at the end of 25th year. And the money in the bank is now divided equally to all members. I want to join this club. I don't know what kind of club is this. Okay, then how much does each member receive? Okay, this is a primary school question if you ask me. Seriously. Okay, now all you need to do is to find out how much money you have, how many members you have, and then take the money, divide by the number of members, done, right? Correct or not? Seriously, is that simple, right? Okay, tell me you know, okay? So he said, yeah, mister, I know. I think my younger primary school brother also know. I agree. But how to find out how much you have? That is the problem. Oh, but then you also notice you have this. You know what is this? This is a formula that allows you to find out how much money you have at the end of n years. So if you make your n to become 25, then you will know how much money you have at the end of 25th year. Am I right? Not very hard, what? Okay, so you say at the end of 25th year, what happened? The amount of money I have, total money. Okay, my grammar not very good because I'm saving time here. Okay, total money doesn't make sense. Total amount of money, I know, but no space, no time. Okay, so this is math lesson. All right, here we go. Tell me you don't know how to press this, I'll be very upset with you, and you should be very upset with yourself too. Okay, so go to your calculator, whatever brand, doesn't matter. You will get this. Okay, I tend to write more decimal places because this is not the final answer, right? So this is the total amount of money you have in the bank after the at the end of the year that it closes down, right? Cool, easy peasy. How many members you have? Well, every year you got 50 members, right? So total number of member. Sorry, very ugly handwriting. Okay, total member equal to 50 times 25. Make a lot of sense, right? Sorry, not money, sorry. 1250 member. So how much they get will be this amount divided by this number. Very difficult or not? Okay, very easy, really. Okay, but you know what? This is very easy, also can be very easily gone, these 2 marks. You know why? Because if you got this wrong, or worse, you left this blank because you don't know how to deal with money, then you got the other 2 marks also gone. Agree? You think what? The total member give you 1 mark? You wish that one primary school kid also have. Right? So you have 1 mark here, 1 mark here. The total member no mark, please. Okay? Otherwise, it's going to be a 10-mark question. Okay, any questions? Any questions? Don't have. Okay, very good. Let's move on. All right, come. We have half an hour, 3 more questions, and these 3 questions are the xiong one, right? Vectors and all. Function okay lah. This is quite easy, quite lame. Except again, some people just cannot function when they are doing function. Okay, but anyway, let's take a look at this one. Okay, an inverse function. Inverse function. Now that sounds weird, right? Because more than 90% of the time, they will give you the function. They ask you to find the inverse. Now they give you the inverse, ask you to find the function. What the heck? Like opposite. Okay, but you better keep your cool, because it's the same. All right. If A is B's inverse, then B must be A's inverse as well, right? Okay, you get what I mean? They are inverse of each other. So this is the inverse of this. That means this is also the inverse of this. Is that all? Is it that simple to understand? That's it. Okay. So don't stress by the fact that how come they give me inverse? I never learned that in my life. Okay, chill. Okay. So actually, all you need to do is to find the inverse of the inverse. That's all. Okay. So you better know the steps. Let y equals to the inverse function. Okay, make x the subject. You better tell me you know how to make x the subject, otherwise I'm going to kill you. Okay, this is like so easy. All right, so you get ey plus 1. Now here comes the catch, or here comes the part that you're going to lose your 1 mark. All right, when you square root both sides, you get square root, like duh. Yes, I know, but you get plus minus. If you didn't write down a plus minus, chances are you're going to get everything wrong already. Okay, so but then you better know that one function for one inverse. Like, come on, if you have this function, the inverse must look like this. You cannot have one function and then you have 2 inverse. Doesn't make sense. Okay, so 1 for 1, as in 1 to 1, right? And stuff like that. So you better know that, hey, one of it must be rejected, and you better know which one. Okay, now the reason you actually have 2 is usually it happens because you have the square root. or fourth root or whatever lah, as long as even power root lah, okay? So every time you got a square, you got this plus minus problem. And whenever you have this square inside, you know what it means or not? The curve is somewhat symmetrical. Okay, I expect you to know already because I mean, come on, x squared, what does the curve look like this, right? Y squared, how does the curve look like this, right? Okay, x squared, y squared is a circle, right? And then x squared minus y squared is a hyperbola, right? They're all symmetrical one. So as long as you got x squared, x squared, whatever lah, in any combination form, they are symmetrical. And when they are symmetrical, there's either a left side, right side, there's an upside, downside. All you need to figure out is which side is this. Okay, so what you do is, of course, you can go to the GC. Actually don't need to use the GC lah. But again, because some of you are so new, okay, I mean, you're new to me, I'm new to you, right? So I don't know whether you know or not. So at the same time, I also want to nag at my own students. Okay, so it's important to talk a bit, but not too much because it's a bit troublesome. See, symmetrical, right? I told you, right? So symmetrical, right? Like I said, two sides, and then you pay attention to the domain. All right, the domain is not there for fun, guys. X more than 1. You know what this tells you? Out of the two sides that we saw just now, right? It is this side. It's the right side. Okay? And you better understand that when you talk about the right side, okay, it is talking about the positive root. Now, this one is not so easy to understand. All right, so some of you probably just want to memorize, and that is fine. Okay? Now, if you want to try to understand a bit more, which I strongly encourage because I always believe in understanding. Okay, if you want to understand, all right, then you can understand it using this. Okay, if you have my functions notes, you'll see this. Okay, I always like to use this as a simple example. Y equals x squared, correct? Now y equals x squared, how does the inverse look like? It's a reflection along the line y equals x, right? And if you draw the reflection along the y equals x, you're going to get this. Okay, and what is this curve? Well, this orange curve is actually y squared equals x. Okay, now pay attention. The orange curve will not be the inverse of the blue curve because at the first place, the blue curve will not have an inverse because it's not 1 to 1. So let's say this blue curve, I go and chop into half. I get the green part. Then the inverse must be the upper half. Cannot be the lower half, or how to be reflected like that. Agree? Okay. So if my invertible function, that means my 1-to-1 function, instead of the whole U shape I cut into 2, it become 1-to-1 now, right? The green part is now 1-to-1, right? The inverse of this green part is the upper half of this curve. And you better know that this curve is actually two curves. All right? It's actually made up by two curves. And it's not hard to tell which one is the upper one, right? The one that's positive root lah. Understand? So if you don't believe, or not say don't believe lah, but let's say you blur, you go and one day you go and press your GC, okay? You go and press square root x. You expect to see the C shape, or the orange color C shape. No, okay? Fat hope, you only need to see this. Understand? All right, so that's why you understand. You understand, then you say, oh, hey, because you never draw the negative root, what? That's why you only appear the positive root. Okay, so if you really want to draw the curve of y squared equals to x, which is the orange color one, you have to draw both in your GC, because only the two combined give you the orange one. Get the point? Now, anyway, my point is to let you understand now that when we talk about the right side of the symmetry, it corresponds to the top side of the symmetry of the inverse. You get me? Right, top, left, bottom. Okay, which means right is the positive root and left is the negative root. You know what? Most students, they memorize. Nobody really need to understand. Okay, but of course, if you want to understand, that'll be the best. Now, how they memorize is this. The teacher probably told them this. Okay, you just have to write down something like that. Since domain of f inverse is equal to 1 to infinity, which is this one lah. Okay, that means telling you on the right side. Then you say, therefore, don't even bother what reject already lah. Therefore, reject this right? This one just write reject first Okay, reject. So you just say therefore, f x is equal to this one, the one that is positive root. Now, some people, okay, later I tell you the marking idea. Are you following? Okay. Now here comes the thing. The question got say state the domain, then you die must state the domain, right? If the question never say state the domain, you still must die state the domain. Understand? Every time you come out with a function, you have to state the domain one. It's a rule. Whether they say or don't say, you just have to follow. I'm sorry, you just have to write down the domain. Okay, all right. So otherwise you get full marks. So what is the domain of f? Pay attention. Not hard, really crazy. So the domain of f is the range of the f inverse. That's it. So what's the range of the f inverse? Is it most of the time when we do a function question, we more or less will draw out the function, right? Like what we did just now, but I erase it. So smart, right? Okay. But anyway, if you recall properly, it looks like this. It looks like this. Okay. It's not hard to guess. Where is that asymptote, right? Asymptote is at 1. Okay, this is x equal to 1 because you cannot non-zero, right? So it must be x equal to 1. So you can see that for x more than 1, the whole curve is just going to go up forever and down forever. Agree? Okay, there you go. So what is the domain of x are all real numbers? Okay, x are all real numbers, and we're done. Hey, 3 marks, guys. How to give? Pay attention. The domain, 1 mark. Okay, the correct function, 1 mark. Okay, and I will give 1 mark for rejecting this. Okay, because if you don't reject, you got this answer by luck. Okay, and by luck means you shouldn't deserve the mark. Okay, because the setter a bit weird. To be honest, the setter should have just set this. Then you can't get the answer by luck already because it must be the negative side. Make sense? Yeah. So usually it's like that, but this setter is quite nice. They want people to get lucky. Okay. Anyway, lucky also don't get you mark because the teacher is not so the teacher is not so kind. Okay. Anyways, are we okay? Quite easy, right? Come, let's move on to this idea called the composite function. This is the part that sometimes students get very I don't know confused. Okay, maybe because J1 then they learn this, and also depend on how the teacher taught you really. Okay, so sometimes it becomes simple thing become too complicated. Okay, let me just tell you first. It sounds complicated. I'm sorry. Okay, but let me explain. F inverse exists if the range of the F inverse is a subset or equal to the domain of F. That's the thing that you have to try to memorize. But I don't advise memorize. I advise understanding, because if you memorize for FG, then you forget GF. Or worse, one fine day, come out GFH. Then you gong gong. Don't know now who is the subset or who now you don't know which one is what. Agree? So it's not good to just memorize blindly or, without context or understanding. I very much prefer you to understand things. Okay, so the logic again, let me just recap. Again, I'm a naggy, right? I'm watching the time, but oh shoot. Okay, so if I have two functions called fg, okay, the two function fg looks a bit like this, right? So you have a g function. Probably your teacher showed you this kind of picture before, right? All right, g first, correct? Then f. So you're gonna jump onto the other one called f. Now the problem is you need to make sure that whatever that comes out of this function must be able to fit into another function that is bigger, correct? So this nonsense that comes out of g, what we call the range of g, must be able to go inside the whole opening of f, correct? That's why it's called subset or equal to the range of, domain of f lah. Okay, so that's the logic like that. It's like a process. So if you one fine day have one machine that looks like this is the first one, right? Then whatever come out. Then the next input like that, you're in trouble because there'll be so much leakage, correct? Not all can go in. Then obviously there's no such thing as a combine them together composite function. Get the idea? All right, so if you can understand, that'll be awesome. Then you don't have to memorize blindly. You don't know f come first or g come first or whatnot. It's always the first function must go inside the second function. Anyways, this is actually much easier than you think. Okay, you just have to explain. So you just have to explain this is true. How do you explain this is true? Well, go and find it lah. All right, so range of f inverse is the domain of f, and the domain of f is, wait, hold on. Okay. Our range of f inverse, we actually got it here, right? Just now we got it here. But anyway, you can do all the relationship with one. It's all real numbers. You should write this down. All right, then the domain of f is, like, seriously, didn't I just look up there? All right, so therefore, the range of f is the range of f inverse is equal to the domain of f. Therefore, f inverse exists. Now, if you write subset or equal, can or not? Can. teacher will still give you the marks, okay? But it doesn't make you look pro, because this is obviously equal. Why you go and think of subset? You know what this means, right? This means it can be smaller or equal to, right? Yeah, subset or equal, right? Yeah, so it's not a proper subset. But the whole idea is you know for sure that they are equal already, then you should just be daring, I'm gonna say daring, courageous enough to just tell people, hey, it's equal, therefore it exists. Good. In fact, when it is equal, there's something special about it. Okay, because when your range of the second function, the range of the first function is equal to the domain of the second function, all right, then you know that the range of this composite function is actually the range of the second one. This only happens when this happens. So knowing that it's equal actually does have a benefit. You don't just gong, don't care lah. Anyway, both will work. Yeah lah, both will work. But if you know that it's equal, you'll know one more piece of information, which probably gonna help you later. See? Okay, so things like that, you get what I mean? You know, you want to know it completely. You don't know blur gong like that. Sometimes correct, sometimes wrong. Anyways, explain why it exists. Explain video 1 mark. Okay, and find this in similar form. This is lame. Okay, f inverse x. Okay, pay attention. F inverse x. You don't need to find out. It's confirm x. That's all. You just need to give the domain. All right, and the domain of the f inverse is the domain of the f inverse. Okay, and the domain of f inverse is given from the start, which is this one. Okay, so x more than 1. Done. Important to understand that f inverse is x all the time. Don't need to gong. We'll go and do this. You know what some people already go and do? They will go and substitute this inside here, and then they get stuck. Okay, now even if you don't get stuck, you are very clever, you simplify, you end up getting x. Trust me. Okay, you end up getting x. It is x. What are you talking about? It is x. Okay, so just you may want to memorize. Okay, because if you go and come back, you come back to square one, make a lot of sense, right? Yeah. Okay, so f inverse is like this. It's like seriously, you go and press calculator. What do you think you come out? Half lah. I mean, you go and sine inverse a half, you get 30 degrees. Then you go and sine at 30 degrees, you get back to half. It's like, seriously? What the heck are you doing? It's like doing this. This is the same. All these are examples of f inverse. You get back the same point that you put in, which is x. Okay, get the point? All right. So I don't think I need to show you more example because it seriously looks weird. All right. So this 2 marks only. All right. The explanation, which means these whole stretch, telling people what's going on, is 1 mark. Okay. This is obviously 1 mark. Okay. That's it. All right. The next one, quickly. Sketch the graph of this. In other words, they're asking you to sketch a line. Sketching the y equal to x. That's all. That sounds really easy, right? Yes, you're right. It's really easy. But please don't go and sketch this and say, oh, Mr. Ang, this is y equal to, because you say it's x, right? So y equal to x. Hello? The domain is not for fun one. Okay? So please don't go and draw this. You should draw this. It's a half line. Not half life, half line. A line that's chopped into half, not even half line, never mind lah. But you get the point, okay? 1 mark, doing this is just 1 mark. This is probably the easiest 1 mark. State the range. This is the part that I was telling you about just now, right? They say state the range. So you got the graph already, what? Obvious to see lah. Don't even need to use this relationship to help you, okay? Because this is too easy. Those hard ones are really, you probably need this kind of thing to help you, okay? Anyways, what am I saying? Okay, the range of this is from 1 to infinity. Okay, 1 mark. Happy? The diagram 1 mark, this one 1 mark. Questions? Okay, don't have. Sounds good. Come. Tada! Vectors. Okay, this one die. All right, now these 2 vectors questions are not the easiest one around, unfortunately. But that's the whole idea, right? Vectors is an evergreen topic, okay? Even for J2s, all right? It is one topic that you will never say you practice enough, okay? So there are some topics that are like that. Vectors is one of them, or the other one is P and C, okay, and probability. That kind of rubbish is like, you're never done studying for it. Anyways, take a look at this one. This is the kind that if you want to do a dot product, you also cannot do because there's no number, right? So what's going on? Let me drink water. Okay, two vectors are perpendicular. Okay, K is a positive constant and A is a unit vector. Now, pay attention. You see, sometimes the question come out like that. 4i plus 4j minus 3k. Then you immediately change to column vector, right? Because I can't stand the ijk, really, I can't. Because and I still got to draw the flying carpet for them, right? This is seriously annoying me. Okay, so I cannot take it that I have to draw the ijk. So I always change it to column vector whenever I can. Okay, now, but that's only for ijk. So please don't go and change this to 1k. Now it will work. You'll be surprised that it actually will work. Okay, but this A and B are actually not your vector component. That means it's not the ijk component. All right. So please don't do that. Your teachers won't like. Okay, even though your answer is correct, but you surely won't get full marks. Okay, because it only works for the ijk thing. Are we good? Can Okay, so ijk. All right, so all this you want to imagine your A as a three-dimensional vector already. Okay, and then your B is also a three-dimensional vector like this. Anyways, what's going on for these 3 marks? Well, what do we know? Well, actually, we don't know anything. The only thing we know is that they're perpendicular. So being perpendicular means if you dot each other, you're going to get 0. That's it. Done. Okay, easy enough? Yep. Okay. So now what? What are you supposed to do? You're supposed to find the magnitude of B, which means you're trying to find out what is this equal to. Okay, and you only know this, like what I just wrote down, right? You only know this. So how am I going to do this? Well, it turns out that there's only one more thing you can do right now, and that's called expansion. Am I right? Okay, so you can expand. So you have A dot A, which is mod A squared, minus away K of A dot B, plus K of B dot A. B dot A is the same as A dot B, minus K squared of mod B squared, equal to 0. The copy guys that this one will cancel away. Okay, mod A squared is 1 because A is a unit vector. So this is 1 minus away K of mod B squared equal to 0. In fact, it's just equal. I'm going to waste time. Okay, so therefore, 1 over K. Mod B must be equal to 1 over square root K. The negative you can throw away lah. Okay, but you may just want to write for fun and reject. Why? Because K is positive, so this is a negative number. Okay, so how can your mod be a negative number, right? So yeah, doesn't make sense. Okay, so 3 marks. Yeah, a bit generous, like you ask me.
In the answer sheet, it says 1 over K.
Hold on. Oh, because it's K squared. Oh dear, my bad. This is K squared, right? Yeah, so it should be 1 over K, plus minus. Thank you very much. Okay. Yeah. All right. Sorry. Oh yeah, I missed out the K square. Okay. So 3 marks. How are you going to give yourself that 3 marks? Let me see. You're getting the answer. Obviously, deserve 1 mark. Okay. And I think the expanding effort must be correct. Okay. The expanding method. The expanding effort involves this thing called the distributive law, right? So you must distribute correctly, and of course, knowing that A dot A give you mod A square, B dot B give you mod B square, that kind of thing. And of course, I think this deserves 1 mark as well, right? Because they're perpendicular means that they dot together give you 0. That sort of things. Okay, so there you go. That's the first part. The next part, this one, I would think is okay. Quite hard. Okay, you see, given that the magnitude is twice of that. Okay, do you know what that means? It means that the magnitude of this is 2 times the magnitude of that. That's all we know. Find the value of cosine theta. What? Okay, it's only got theta come out. What's theta? Theta is the angle between A and B. Now, you probably want to remember that the only thing that can relate theta with A and B is this formula called the dot product, right? Okay, so that's the only thing that can relate the theta, and in fact it's cosine theta, so of course you better be thinking of this. But how on earth are you going to get this into the picture now, right? Knowing this only, it's a difficult call, really, not straightforward. So, but it's something that you can't say you don't know, okay? Because it's something that you already seen over here. The way I highlight, very messy. Okay, let me explain what do you mean by you already see over here, right? You already saw it happening, and that is this one, right? A dot A equals to mod A squared. I mean, when you do A dot A and all these things, you never beat it. It never blink, right? You just do. You just say, okay, it's normal, it's obvious, right? But now when you suddenly face it this, right, then there's a difficulty in trying to see things going on. Okay, what do I mean? Pay attention. The trick is to square both sides. Then you're going to get 4. Agree? Okay. Now, but then you say, Mr. Ang, what's the big deal, right? Like square both sides for what? Well, you see, when you square both sides, you actually have this. Now, what I want you to see is that this, see it as this, and can you see this happening? You see, the whole idea is you need some A dot B's around. Okay, and with the mod, there's no way you can have an A dot B. But when you square the mod, you actually have the dot itself, right? I mean, itself dot itself, like if you like. Okay, so A dot A, right? So this is essentially this. And when you expand this out, which you will shortly, you are going to have A dot B inside. And that's how you're suddenly going to have your cosine theta. Remember, your job is to try to get cosine theta. Agree? Okay, cool. Come, let's do it. All right, so the distributive law again, mod A square plus 2k A dot B. Agree, Can, A dot B k, A dot B k 2ab, A dot B lah. Okay, then next one is k square mod B square. All right, is equal to 4 times of mod A square minus 2k square A dot B. Okay, and then plus mod B square. Follow? Okay. Say yes, Okay, come. Mod A square is 1 because A is unit vector. It's the same question, by the way, so don't blur, Okay. So we're gonna have 1 plus 2k. I have no idea how to deal with this, but leave it alone first, okay? I'm not about to introduce in the cosine yet, okay? Because there are more things to do right now. Remember this fella? See that? Yep. That's a good news. So that's going to be 1, right? K square times 1 over k square. So I'm going to get 4 times of 1 minus away 2k square. Hold on, this is a k square, right? Oh, no k square. 2k. Yeah, why this one got square? My bad. Okay, so 2k A dot B plus 1 over k. 1 over k square. Sorry. Okay. So far so good? Okay. No. I think I made a mistake here, right? That should be a k square. Yeah, no space. Okay, here we go. Right. Yeah. All right. So it's 2 plus 1, right? Yeah, it should be quite symmetrical, all right? It should look about the same. Okay, sorry. Somehow I missed it. Okay, here we go. What are we up to? Remember our mission. Our mission is find cosine theta, right? Okay, so not quite there yet. But we know we're into something because we see a dot B and we see a lot of k's being cancelled away, and then suddenly we have something that looks so simple. Okay, something that looks so simple. I think that's good news. So I'm going to have 1 plus 1, which is 2. 2 times 4 is 8, minus away 8k A dot B. Now it all sounds very weird, but I'm going to get 10k A dot B. Is equal to 6, correct? Oh, great. So I'm going to get A dot B. Now is the time to introduce in what the heck is A dot B, right? So A dot B is mod A, which is 1, mod B. Okay, I know what, I'll just write down first, okay? Cos theta, all right? That's where the cos theta comes in. Then you jolly well knows or remember that this is 1, this is 1 over k, and this is your cos theta equal to 6. So therefore, cos theta is equal to 6 over 10, 3 over 5. How many marks is this? 4. Very stingy. Okay, but anyway, this question is a bit harder. Okay, because again, if you miss this, or you never think of this, you're quite dead already. I think seriously, there's no way to wiggle out of this. Okay, if you have some other ways to wiggle out of this, tell me. Okay, that means without doing this square and without noticing that your square is actually a dot a. Okay, I mean not a dot a lah. What I mean is, something dot something is that something mod square, right? Yeah. Okay, so this 4 marks, of course, getting the answer is 1 mark. Okay, I think a lot of expansions around, so you deserve a few marks for expansion. I will say that being able to see through the square is important, 1 mark. Being able to see here to here is 1 mark. All right, and of course, in between, the expansion correct, 1 mark. Because the expansion correct will lead you to the correct answer. And if the expansion is wrong, then unfortunately, you're going to lose 2 marks in a row. Okay? Any questions on this? Quick. Okay? All right, now this is the kind of vector question, like I said, you want to do a dot product, also cannot do because you don't have numbers, right? So sometimes I call it the no number question, or if you like, some schools, they call it abstract vectors. Abstract, very, very abstract. Okay, come, let's take a look at this one. Nice. All right, this one got planes, okay? And this one has got a lot more marks. How many marks is this? Oh my God, it's like 10 marks question. Okay, let's not waste time. The plane contains the origin and is parallel to these 2 vectors. Find the equation of the plane. That's all. All right, so that's the mission. Your job is to go and find the equation of the plane. First thing that you want to ask yourself is, what do you need to find the equation of a plane? It's just like if you want to find a line, like in secondary school, right? A line, the equation of a line. What do you need? You immediately must be able to tell, oh, I need a point and I need a gradient, right? Because I know the gradient, I know the point, I can find the equation of the line. So if you want to find the equation of a line in vectors, you also need a point and a direction. Correct? You need a point and direction. Now we are talking about finding the equation of a plane. So if you want to find the equation of a plane, what do you need? You better have the basic idea that to find the equation of a plane, right, you must have at least 2 directions and 1 point. Okay? So 2 directions and 1 point. Then the 2 directions cross each other, crisscross, will give you the normal, right? So another way is to have the normal and a point. Okay, so you must have this because otherwise you can't find the equation of plane. That's like the basic ingredient to make it happen. Are we all good? Okay. So if you look at this question, it's actually quite easy, really. Okay, because parallel to these 2 vectors means these 2 vectors are on the plane already. Okay, so if you want to visualize, it looks a bit like this. Okay, this one is the -1, 0, 1. This one is the 1, 2, 0. They are the direction. So all you need to do, they want the scalar product form, which means that r dot n equal a dot n form. Okay, so the normal -1, 0, 1. That's it. Okay, so you get the normal. Cover the first row, we're going to get 2. Cover the second row, we're going to get 1, which is -1. Cover the last row, we're going to get 2. Okay, so 2 minus 1, 2. All right, and that's the normal. So r dot n is equal to 0. That's the equation of the plane. Now, a few things you do want to know. Okay, whenever the plane contains the origin, the right-hand side confirms 0. You better know. Okay, all right. Every time you see r dot n equals 0, it means that origin is on the plane. Okay, all right. If you haven't knew it, you better know now. All right, unless of course it's like r dot something equals to 1. Then of course this is not, it doesn't contain the origin. Okay, but every time it is equal to 0, it will contain origin. You can memorize it, you can understand it. If you try to understand it, how to understand, it's not that hard, to be really honest. Okay, so the formula, if you like, is called r dot n equal a dot n, correct? Yeah, it's like y equal mx plus c. So r dot n equal a dot n. So what is a? A is any point on the plane. So if you got origin, then you just put 0, 0, 0 all the time. Then of course every time you dot, you get 0. Okay, so this is I would say an important piece of information sometimes, because some question, right, they'll give you the equation, but they don't tell you origins on the plane. Somewhere along the way, you actually need 1 point. Okay, and then you never realize that, ah, yeah, actually origin is on the plane. Because if you realize it, if you can use the origin as a point that's on this plane to solve whatever you're trying to solve, it usually can help you faster. Okay, so trust me, okay, I think it's an important thing to know. All right, so 2 marks, how to give. I think you get the normal correct, you get 1 mark, and you get this correct is 1 mark. Okay, so that's it. Seriously easy. Let's move on. I have a point called P. Okay, by finding the foot of perpendicular n of point P to the plane, show that the position vector of the mirror image of P in pi is this. It's a show question, so the answer is right there staring at you already. Okay, but what's going on? Now, again, I advocate sketching. So I don't know about you, but when I do vectors like this, okay, I always like to imagine I can see things. Okay, so for example, like in this particular case, I actually have a plane. My plane's so ugly. One more time, try another one. This is more like it. Okay, all right, I actually have this plane, right? Now I have a point called P, which better not be on the plane, because if it's on the plane, then it's a very lame question, isn't it? What mirror image when it's on the mirror, right? Okay, so this point P comes down. This is called a foot of perpendicular called N. All right, and by finding the foot of perpendicular, means I need to find these first. Number 1 question mark. Okay, so I need to find N first. Okay, first thing first. Then I need to go and find the mirror image, which is the reflected point, which is somewhere down here. Maybe we go P prime. So second question mark, first question mark. So there are 2 things to do. All right, so better know how to do. All right, so how do we do the first one? How to find the N? Well, it turns out actually quite easy. If you just look at this diagram, you want to understand that this point N is actually the intersection point between this line and this plane. Okay, now how do you find intersection point? Come on, you learned this in Sec 2, right? You already learned in Sec 2 when you say you solve simultaneous equation, you're trying to find intersection point, right? So you learn in Sec 3 some more, because Sec 3 you learn curve, right? If I want to find intersection points between the line and the curve, I solve simultaneous equation, correct? So now in A level, you still learn the same thing. If you are trying to find intersection point between a plane and a line, you're just solving simultaneous equation again. Every time intersection means simultaneous equation, right? Which means you better have the equation. Am I right? So good. The equation of plane, you have. There you go. That's the equation of plane. How about the equation of line? Don't have. How to find? Well, what do you need to find equation of line? So equation of line, you need a point and direction. So equation of line Pn will be r is equal to point plus lambda, no space. What is the direction? Direction must be normal, right? Okay, here we go. Lambda real numbers. That's the equation of the line, the vertical line there. So when you are trying to solve a simultaneous equation, of course, in vectors, we always do substitution. So this is the R. I'm going to put this R inside this R. It's called simultaneous equation by substitution, right? So it says sub into pi. Again, our presentation is pretty important as well. So please learn to write nicely. Okay, there you go. All right, you better tell me you know how to do the dot. So you're going to get this minus this plus this plus this equal to 0. So I'm going to have 9 lambda. Is it 9 lambda? Looks like it. Okay, 9 lambda is equal to 9 minus 9. Correct? 10 minus 1 is okay. So lambda equals to minus 1. So once you get lambda equal to minus 1, put it back here and you get the point N. 1, 2, 0. That's the point N. Okay? Okay, now that's not the end of the story, okay? Because we have another thing to do, and that's the y prime. Now, looking at the diagram, how do you think we do the y prime? Sorry, the p prime. All right. The truth of the matter is, there are quite a few ways to do this. Okay? But I like to use the easiest way. Now, some school teacher will teach you to use the midpoint theorem. Yeah, it is true. because this has to be the midpoint, right? And of course, if you know the midpoint theorem, you can get there. But again, I think that's a bit overkill, because the truth is, if you take a look at this, right, this is 1, 2, 0, right? And the 3 points are collinear like this, and you know that they are equal. In fact, they are not only equal in length, they're equal in direction, depending on how you want to look at the direction. Agree? So I would think that Pn is actually equal to n p prime vector. All right, coming down is equal to coming down. Please don't come down equal to go up. Doesn't make sense, right? Okay, so come down equal to come down. That makes a lot of sense. So far, so good. Okay, now what's going on is that you notice that Pn is On minus OP, and Np prime is OP prime minus On. And if you look at this equation that I just formed, you have this, you have this, you have this. You are finding this. Not difficult. Okay, yeah. So seriously, it's not that difficult. All right. So there you go. You straight get the answer. Pn, OP prime is equal to 2 times of On minus OP. And you should get the answer minus 1, 3, minus 2. That's OP prime. I like this because it makes it simple. Okay? Simple to the point that you don't even need what midpoint theorem, no need. It's just equal vector that you learn in secondary school anyway. Alright? Two vectors are same in direction, same in length, they're equal. Done. Oh, it's simple. What for you go and think and do so hard? Okay? Alright, so I like to keep things easy, and I think you should. Alright? 3 marks. Correct now? Yeah, 3 marks. Okay, 3 marks for doing this. How do you allocate 3 marks? Now, if I were you, I mean, come on, getting this must be 1 mark lah. Getting this must 1 mark, right? Okay, so where does the 1 more mark go to? You tell me. The 1 more mark is very hard to say already, right? Is it the simultaneous or is it this? Okay, now you may think that this doesn't deserve 1 mark because Mr. Ang so simple, 2 line only you get the answer. But I tell you, some people use midpoint theorem. Then you don't give them 1 mark, not fair, right? Midpoint theorem is a few steps now. Okay, so I am thinking this is a more deserving 1 mark compared to simultaneous equation. I mean, simultaneous equation everybody knows how to do. Okay, so actually this question quite stingy. It should be 4 marks because this dot product deserve 1 and this one also deserve 1. Okay, it should be 4 marks. Okay, but never mind. We can't choose the marks, but we just have to make do with it. Roughly there. You get the point? Okay, again, the marks is the second thing that you should be focusing on, right? The first thing you want to be focusing on is how to do it, okay? And can you actually do it all by yourself? All right, there you go. That's part 2, we're done. Let's move on to part 3, shall we? The point Q is this. Find the exact length of projection of PQ onto the plane. This one is a good question. Okay, this one is a good question because some joker, you know, they memorize formula, which is not wrong, not their fault, okay? Because teacher will probably ask you to memorize anyway, right? So when they see the word projection, they straight away think of the formula A dot B cap. Because their formula called A dot B cap is actually the formula for projection of A onto B, correct? It makes a lot of sense, right? So when they start thinking about that formula, I need to have something dot something cap, then they think, oh, pretty obvious, I need my PQ, right? Okay, which is not too far off. My PQ is OQ minus OP. Where's my P now? P is there. 3, 1, 2, correct? So I'm going to get 1 minus 1 minus 1. What kind of rubbish number is this? Okay, but anyway, I'm going to use this to dot something, correct? A dot B cap. Well, I found my A already, right? I need to dot something cap. So then you say plane. Okay, now look at this plane. Is there anything for me to dot? Well, it seems very obvious is that the normal is the only direction that is the most prominent, correct? So chances are people are just going to do this. Okay, they're going to do okay, I'm going to take this A dot B cap, which is this. Well, that's my length of projection. Unfortunately, this is wrong. Okay, let me explain why this is wrong. Okay, now you better know your right angle triangle quite well. Again, this is called nagging session, right? Which means it's revision. So A dot B cap looks like this. Okay, A is always the hypotenuse side. B is always the so-called base. Understand? So this formula is what we call the A dot B cap mod. All right, again, you can memorize, but of course, I hope you can understand this. It's actually the trigo tuakaso. That's all, very simple one. Okay, the explanation is quite simple. Okay, and that is why this is called A cross B cap. Okay, because this is the opposite side. All right, which is the sign. Cross product is something to do with sign, right? Okay, the dot product is something to do with cosine. So anyway, so when you do A dot B cap, which is always what we call A project onto B, right? So that's how people memorize, which is not too bad a thing, right? Like, okay, I know that. But you see, when you do this, when you do like what this joker is doing, okay, you see, when you have a plane, and then you have a PQ, and the plane, what you do is you go and dot with the normal, you actually get this projection onto the normal. Do you agree? You get the projection onto the normal. That's not what they want. What they want is the projection onto the plane. Get it? Okay? So please do not memorize the formula without context. Okay? You want to memorize the formula, yes, but you want to memorize the formula in a way that it works. Not just see the word length of projection means must be this formula. No, you have to learn how to use it properly. Okay? All right, so anyways, so this is the wrong answer, by the way. You know why is it wrong, right? Because you end up getting this length, which is not what you want. Right? What you want is a shadow on the plane, not shadow on the normal. Okay? So in short, if you were to draw the diagram one more time, it looks a bit like this. All right? So that's the P, that's the Q. All right, so what you want is actually this. Okay? And you also notice that the normal is actually over here. So if you complete the right angle triangle, which is this one, right, then this length is what you're looking for. And this length is not the A dot B cap. It is the opposite side. Okay, because the angle is here, right? So it's the opposite side. It's the cross. All right. So to do it correctly, yes, you take this PQ, but you cross with the B cap. Not dot. That is the required length. Okay? I got no space. Hold on. Okay, so that's the required length. Of course, I trust that you can do this yourself, which is just dotting, crossing, and that's all. Right, so the required length is equal. All right, so it's 1/3 mod of this crossing. Come, let's try to cross this together, shall we? All right, cover the first row. I'm going to get -2 minus -1, which is -2 plus 1. So that's going to be -1, right? Cover the second row. I'm going to get 2 minus 2 becomes 2 plus 2, which is 4, -4. Then the last one is going to be -1 minus, so it's a -3. And we're all negative, and this is a very negative number. All right, so 3, yeah, 3, 4, hold on, -1, 1. The first number correct? 3, 4, -1. Okay, I think I crossed somewhere wrong. Hold on 1 minute. Can you help me check, please? -2. Minus 2. Oh, cover the first row. Wait, hold on. -2 minus 1 is -3 lah. Yeah, sorry, my bad. Okay. Then the second, the last one looks wrong. -1 minus. Hold on, cover this one. Correct? Okay. So we have -3, 4. Then the last row is -1 plus 2. -1 plus 2 is how much? 1, right? Yeah, so this number is 1. Okay, so it's like this. Yeah. Okay. Yeah. Sorry. All right. So we have we're gonna mod this will be 3 squared. 3 squared is how much? 10 plus that's 20. 26. So what kind of rubbish answer is this? Okay, so square root 26 over 3. Hold on, let me check. Okay, good. Thankfully, it's correct. Okay, so this green part, 3 marks. Wow, this 3 marks is like so short, the working, right? You see the other 3 mark that we did just now? So long, right? So if you know how to do, things are not that bad. Okay, so of course, how do you get the 3 marks? Getting the answer is 1 itself. Getting the formula correct. I don't know whether probably PQ correct also give you 1 mark. Okay, because too many marks already. The setter also not very consistent. Sometimes stingy, sometimes not so stingy. All right, last one, hence or otherwise. Of course, we use hence, right? Hence usually means it's the faster way to do things. Okay, so hence, find the exact area of the triangle PNQ. Where's PNQ? Where's? Oh, okay, I have no idea what they're talking about. But anyway, you know what? We should have a quick drawing. All right, where is N? N is below P, correct? Okay, so you probably want to have a quick sketch of things. I have a point called P, and down here this is called N. N is on the plane, right? Somehow I got the PQ, and what I just found out was that the length of the shadow, which is this length, is square root 26/3, correct? And I'm trying to find the area of this. Okay, so what do you think you do? Well, you see, when you come to vectors and you are trying to find area, right? The first formula that should come to your mind is this. I don't know whether you know, you better know, right? A cross B mod, you actually get the area of the parallelogram that's spanned by this AB vector. Means if I got one vector A, another vector B, right? This parallelogram will have the area of A cross B. Okay, so every time you have an area question, you will think of this formula. Now, of course, in this case, you could have just take PQ, which you already have, right? Go and cross PN, which you also have. I mean, over here, there. Okay, so we have PN, we have PQ, right? All the vectors we have. So it already gives us these two sides, correct? Cross them, half it, that's your area of triangle. You're done already, actually. Okay, so that's the area of triangle. This is one method. Okay, just do it properly, you'll get the answer. But I don't like this. Okay, why I don't like this is because you are not hence. Yeah, or rather, you're not using the hence. Okay, so this question, thankfully, it says hence or otherwise. So you get past it, you get the 2 marks because there's otherwise. What if there is no otherwise? Die, hence. Meaning to say what I just discussed, which is this cross product thing, you're going to get 0 anyway if your answer is correct. Okay, because you are not using the answer you found. So if you want to use the answer you found, what do you think you do? Quick. Come on. What do you think you need? Not hard, what? If you look at this, it's really just half time base time height. Agree or not? Can see the half time base time height? Okay, so you already know the height, what? If you like, you call this the height, then you just need this, the base, which is the Pn. Pn length, if you like. Okay, so you can say that the area of triangle is equal to half times Pn times the square root 26/3. And that's it, lah. Okay, so what the heck is this Pn thingy nonsense, right? Do we have it on the ready? Let me see. Pn. Unfortunately, just now I didn't work it out, right? I should have just worked it out. Okay, so On minus OP. Ayo, so messy. Where's my On? On is this one, right? On is 120, and OP is this one, right? On minus OP. Yes, okay, correct. Okay, otherwise I scroll up and down. Okay, so this is going to give minus 2, 1, minus 2. All right, so if you mod this, by the way, this Pn, in case you lost. Okay, so if you go and mod it, you're going to get 4 plus 4, this is 3. Okay, so it's going to be 1/2 times this times this. Okay, do you understand what's going on? Okay, all right, so this blue color, this light blue color method is the so-called hence method, right? Rather than the brute force by crossing them. But of course that will work, and I think you understand. Okay. Any questions, anyone? Okay, good. All right, good. We didn't overrun for too long. You see, some of our friends already left. I don't know. I guess probably some of them haven't learned vectors. Some of them haven't learned vectors. Probably not tested, and some of them probably have to rush somewhere. So we're done. Yay! Okay, so it's not half as long as I thought it will be, but thankfully that's okay. Right. Any questions you may have, you can ask. Actually, I don't know how many of you actually got questions. You can just ask. Don't have. No questions at all. Okay, all understand. Okay, all understand is good. Okay, so I hope that helps you with your revision. All right, kickstart your own revision or whatnot. Okay, so anyway, so if you have no further question, I'm gonna end the meeting already. All right, so you guys take care. But of course, if you have any questions suddenly to thought of, I don't know, you can ask me. I'll try my best to help you. Okay, Ken? All right. All right, no further question, then I'll just say bye-bye, okay? So bye-bye, take care, guys.
Thank you.
Okay, thank you, bye-bye.